We can start today's class. Last time, we have started to discuss collision, but that is just a start. Today we are going to continue that part. That is the last part of this lesson. Then we can complete that lesson. And Tuesday, as I like as I informed you earlier, Tuesday there will be a class from the morning to evening, not a full day, but up to 3:30. From 6:30 a.m. Initially, you will be given a MCQ paper in Tuesday class. Therefore, please log into the class exactly at 6:30. 6:30 or 7, I will let you know. 6:30 okay, 6:30 okay, because then we can do some questions. No? So please log into the class at exactly 6:30. Then you will be given MCQ paper. This is not a exam. This is not the exam. But then, so prior to exam, you will be given some revision paper. Then uh, Tuesday, we will discuss some special questions regarding this theory parts. And therefore, today we are going to complete balance theories. Then Tuesday we will discuss the last practical, and questions with it. Okay, shall we start? So, in last time we have started to discuss collisions. You know, as we discussed, there are several stages in collisions. No, so as we discussed in the class. So if there's a collision initially, definitely there should be a relative motion between two objects. Then the initial state means the stage of collision, the stage of contact. So during the collision, the first thing that we can observe is a collision. A collision means a contact between two objects for very short time period. Contact between two objects for very short time period. Put it. So due to that contact, actually this contact is a very short contact. This contact is available for very short time of period. Put it. So due to this reason, there will be a impulsive forces exerted on each object. Impulsive forces. So now these impulsive forces are equal and opposite to each other. Actually, those are impulses put it. So due to this impulse, the momentum of this object can be changed, and the momentum of this object can be changed with it. But if we consider this one as an entire unit, then there is no external force exerted on this object, on the system. Therefore, if we consider the entire system as there is no external forces, definitely the momentum of the entire system should be equal, because I into this side and I into this side will be cancelled out. Therefore, there is no net change in momentum. But if we consider about a single object, there may be a change in momentum, and there may be change in momentum. But if we consider about the entire system, the change in momentum will be zero. Therefore, when we are analyzing this kind of system, we can use conservation of linear momentum. That means linear momentum conservation. We can use linear momentum conservation principle for this kind of collisions. when it is required to analyze. Okay. That is this stage number one. So after this impact or after this contact for very short time period, then what will happen? Due to this impulsive force, what will happen to this main object? This object can be deformed. It can be deformed means its shape can be changed. This object can be deformed. Those kind of deformation may be visible, or sometimes it may not be visible to them. Okay. Therefore, according to the type of material, these deformations can be seen, or sometimes we cannot see. Okay. So if you consider about a ball, a clay ball, if you consider about clay ball, then you can clearly see the deformation, no? So if we apply force on a rubber ball, then again we can see a deformation. But if we apply force on a very rigid metal ball, although there is a deformation, we cannot see the deformation. That is very, very small deformation. Therefore, according to the type of material, of this object, this deformation can be seen, or it may not be seen. So, again, according to the properties of this material, some material can recover this deformation. That means once there's a deformation, the deformation will be recovered by this material. Something like rubber ball, no? So if you deform a rubber ball and if you release that force, then initially rubber ball will be deformed. Its shape will be changed. But once we release our force, what will happen? It will restore Buddha. That means it will come to the original shape. Therefore, according to the type of some material can recover this shape change Buddha. So that process is called elasticity. That means if any object can restore the deformed position, such kind of object can be considered an elastic object. Therefore, elastic objects can restore their original shape after the collision. But there are some objects that they cannot recover to the original shape. The most convenient example is clay. So if you use a clay ball and do a collision, definitely it will deform, but it will not restore to the original position. That is because of their properties of that material. So that material is not an elastic material. So if it is elastic material, then definitely its original shape will be, it can be recovered. So materials that cannot recover their shapes is called as inelastic material or plastic material. And inelastic material. And therefore, that is the last part we have discussed in our previous class today. So there are two types of material, elastic and inelastic. Inelastic material, they can recover their original shapes after the collision. But if you consider about inelastic material, they cannot recover. Okay. So according to that kind of collisions, we can divide the collisions into two types. One is elastic collision, other one is inelastic collisions. So in elastic collisions, those objects can recover their original shape. And in elastic collisions, they cannot recover their original shape, or actually or they actually sometimes they can recover, but they will consume some energy to do so. Okay. Then you know, according to the type of material, some materials actually will not undergo any deformation. That means if there's a deformation, or actually if there's any deformation, the deformation is very, very small one, and we can neglect that thing, especially a metal ball. So if you call it two metal balls, then actually you cannot see any deformation. Therefore, such materials will not undergo this second process. That means it will not deform. And so if it is deformed, and during the recovery process, that process will consume some energy. So due to that energy consumption, the initial energy of the system will be reduced. Initially, they have a kinetic energy. Both objects have a motion. Therefore, initially, the system have a kinetic energy. During the recovery process, some energy of that kinetic energy will be used to recover this deformed object. Therefore, during recovery process, some energy can be consumed by those materials. Therefore, its original energy can be decreased. So, if the original energy or the initial kinetic energy is decreased, such kind of processes, such kind of collisions are called as inelastic collisions. Inelastic collisions. Inelastic collisions. Inelastic collisions. If there's no energy consumption during the recovery process, such kind of collisions are called as elastic collisions. So that is a little bit different than the elasticity and the inelasticity, but elastic collisions are the collisions that there is no energy consumption during the recovery process. Inelastic collisions are the collisions if there is a energy consumption during the recovery process, such kind of collisions are called inelastic collision smoothing. And so that is the difference between elastic and elastic collision smoothing. And sometimes those collisions are further divided into elastic collisions and perfectly elastic collisions, inelastic collisions and perfectly inelastic collisions. And but uh, that word may sometimes that word is used, sometimes that word is not used in some cases. But according to the given question, we have to understand what is the situation is with it. And ඒක තේරුම් ගන්න පුළුවන්. Okay. Therefore, those are the type of collisions and characteristic of collisions according to the type. Therefore, if we consider about an elastic collision, if you consider about an elastic collision, it is very clear there is no energy consumption during the recovery process. Therefore, not only the momentum but also the kinetic energy also conserved during this collision. Therefore, we can use energy conservation law during this kind of process. But here, if there's an inelastic collision, definitely there's a reduction of kinetic energy. Therefore, we cannot use energy conservation law for kinetic energy conservation during this collision. Therefore, we can only use energy conservation. We can only use linear momentum conservation here. But we cannot use energy conservation here because there is an energy loss during the collision. Therefore, if you are given an elastic collision, you can use two relationships. One is linear momentum conservation, other one is energy conservation. But if it is an inelastic collision, you cannot use energy conservation because there is energy loss during the recovery process. There's energy loss during the recovery process. Is that clear? If it is clear, please raise the hand. Devanathan. Anityanand. So I need responses from everybody. If you did not understand, please give me a feedback. තේරුම් නැත්නම් කියන්නේ. Sasinder. That's it. හරි. ඔතන පුතේ අර perfectly elastic කියන එකයි elastic කිව්වම දෙකම එකයි ඒක වෙනසක් නැහැ. ඒක වෙනසක් සාමාන්‍ය අපි ඒ කියන්නේ maths වලට ඒක අරගන්නවා. maths වලදී perfectly elastic කියන එකයි elastic කියන එකයි අතර difference එකක් අපි අරගන්නවා. මොකද එතන අර මේ අර E කියන factor එක වෙනවා. එතන අපි maths වල දෙක අපි use කරනවා. හැබැයි physics වලදී අපි ඒක ඒ තරම් දුරට consider කරන්නේ නැහැ. elastic කිව්වහම ඒක අර perfectly elastic ම තමයි සාමාන්‍යයෙන් consider කරන්නේ. හරි. හැබැයි ඉනිලාස්ටික් එකයි perfectly inelastic කියන කතන්දරේ අපි ඒ දෙකම ගන්න. හරි. physics වල inelastic කතන්දරේ perfectly inelastic කතන්දරේ දෙකම ගන්නවා. හැබැයි elastic වලදී මේක elastic perfectly elastic කියලා කියන්නේ නැහැ. හරි. maths වලදී එක කතා කරනවා. Okay. They write on this. In physics, come on, perfect elastic collisions are called as elastic collisions only. How do you know the better? If there's energy consumption, if there's energy loss, if there's energy loss during the recovery process, if there's energy loss during the recovery process, if there's energy loss during the recovery process, such kind of collisions are called inelastic collisions. Inelastic collisions. Therefore, we cannot use energy conservation. We cannot use principle of energy conservation, principle of energy conservation, principle of energy conservation. Therefore, we cannot use principle of energy conservation. I will repeat. Okay. If there's energy loss, if there's energy loss during the recovery process or during the collision, if there's energy loss during the recovery process, such kind of collisions are called inelastic collisions. If there is energy loss during the recovery process, such kind of collisions are called inelastic collisions. Therefore, we cannot use the principle of energy conservation for inelastic collisions. Therefore, we cannot use principle of energy conservation for inelastic collisions. Underline that sentence. Okay. Right. So those are the elastic collisions, then inelastic collisions. But then there is another main type of collisions, perfectly inelastic collisions. Perfectly inelastic collisions. Perfectly inelastic collision. What the perfectly inelastic collisions means during the collision, that means during the recovery process, if there is a maximum kinetic energy loss, if there's a maximum kinetic energy loss during a collision, such kind of collisions are called perfectly inelastic collisions. Maximum kinetic energy loss means not entirely lost. Sometimes it may be entirely lost, but it is a maximum loss. Maximum kinetic energy loss during the collision. And so, maximum kinetic energy loss during the collision occurs when there's a collision. When there's a collision, suppose now there's a collision. Here M1, here M2. So after the collision, if these two objects move together with the common velocity, then such kind of incident, during such kind of incident, there is a maximum kinetic energy loss. Maximum. එහෙනම් maximum kinetic energy loss එකක් තියෙන පුතේ අනිවාර්යෙන් මේ දෙන්න එකට කම්බයින් වෙලා යන වෙලාවයි. මේක ඔයගොල්ලන්ට ඔප්පු කරන්නේ නැහැ. මැත්ස් කට්ටියට ඔප්පු කරන්න පුළුවන්. මැත්ස් කට්ටියට කොලිෂන්ස් පාඩම් කරාට පස්සේ මේක ඔප්පු කරන්න පුළුවන්. හරි. Okay. now අපි බලමු. මොකද වෙන්නේ කියලා. හරි. So this is the characteristic of perfectly inelastic collisions පුතේ. හරි. මේක දැන් මෙහෙමයි. දැන් අපි දැන් හිතන්න මෙහෙමද? අර මැටි නැත්නම් ක්ලේ එකක් අපි බිමට ගහන්නකො. ක්ලේ එකක් බිමට ගවුවට පස්සේ මොකද වෙන්නේ? kinetic energy එක maximum loss වෙනවනේ පුතේ. දැන් එතකොට එයා කොලිඩ් උනේ මේ මොකක් එක්කද? earth එකත් එක්ක තමයි කොලිඩ් උනේ. දැන් earth එකත් ඒ කොලිඩ් උනා earth එක යන්නේ නැහැ. ඒක නිසා එයා මොකද උනේ? earth එකත් එක්ක ස්ටික් වෙලා තියෙනවා. earth එකත් එක්ක ස්ටික් වෙලා තියෙනවා. earth එකට ස්ටික් වෙලා තියෙනකොට තමයි එයාගේ maximum kinetic energy loss එක වෙන්නේ. එතකොට maximum kinetic energy loss එක කියලා කියන්නේ fully kinetic energy loss එකක් වෙන්නත් පුළුවන්. හැබැයි ඊට වඩා අඩු එකක් වෙන්නත් පුළුවන්. ඊට වඩා අඩු එකක් වෙන්නත් පුළුවන්. හැබැයි වෙන්න පුළුවන් maximum එක. ඒ කියන්නේ object දෙකම move වෙනවා කියලා හිතන්න. ඒ object දෙකම move වෙනවා නම් kinetic energy එක තනි කරගෙන fully loss වෙලා නැහැ නේද? loss වෙනවා. හැබැයි fully loss වෙනවා නැහැ. So in such cases the maximum kinetic energy occurs when the objects are stick together after the collision. Okay. So this kind of collisions are called perfectly inelastic collisions. So perfectly inelastic collisions, there is a maximum kinetic energy loss. Maximum kinetic energy loss, and the characteristic feature is after the collision, two objects are moving together. Together means they will stick together. That is the characteristic feature. And then we cannot use energy conservation law for this case as well as this case, but we can use both momentum, linear momentum conservation and energy conservation for elastic collisions. Although there is energy loss, momentum is conserved. Momentum is conserved. Therefore, we can use linear momentum conservation for these two cases. Because there is no external force to it. So if there is no any external force, no matter what will happen to the energy, the momentum will be conserved. So if there is a force put it, then only momentum is changed. So if there's no external force exerted on this entire system, then the momentum of the entire system should be constant. If you got that one, please raise the hand. So what is the definition of force? The definition of force is equal. It is the rate of change in momentum. Therefore, if there is a change in momentum, definitely there should be a force. On the other hand, to change the momentum, definitely there should be a force. Otherwise, we cannot change the momentum of any system or any object. So, if there is no external force exerted on the system, then definitely the momentum of the system should be conservative. No matter what will happen to the kinetic energy, definitely momentum should be conserved. Okay, I will give you example. I will give some example. Okay. Okay, I will give a table, and during the table, I will explain it again. Okay. Okay. Balan. Inelastic. Inelastic. Perfectly inelastic. Before the collision. Before collision, they will separately move with different velocities. Before the collision, they move with different velocities in any direction. V1, M1, V2, M2. So before collision, so all are same. V2, M1. V1 and 2. On the before collision. දැන් බලමු collision වුණාට පස්සේ මොකද වෙන්නේ කියලා. After the collision. පුතේ දැන් ඔන්න අහගන්න ඕන. Please listen to me very careful. But Puti, in some cases, during the collision, there are two stages. First stage is contact stage. Okay? First stage is contact stage. So during the contact stage, definitely there will be equal and opposite impulsive force exerted on each object. So this is the contact stage. The second stage means deforming stage. So due to this impulsive force, these two objects can be deformed. Puti. They can be deformed. So according to the rigidity of that object, those objects can be deformed. So some objects are highly rigid Puti. Therefore, highly rigid object cannot be deformed easily. But some objects are very flexible, so they can easily deform. Therefore, so during the collision, during second stage is deformation, then the next stage, so after deformation, they will try to recover, Puti. Recover. Therefore, to recovery process, definitely it will consume some energy. That energy will be absorbed through the initial kinetic energy of those particles. Initially, they have energy due to their motion. They have kinetic energy. So, these objects will use those kinetic energy to recover to the initial shape. Therefore, some energy will be lost due to this recovery process. Therefore, some energy can be lost. And therefore, if there is energy lost, that such kind of collision is called as inelastic collision. Inelastic collision. Because there's energy lost. And therefore, if there's energy loss, that means if there's a collision like that, and collision actually may collisions with flexible bodies. And if there's a collisions like that, definitely there will be energy loss. Therefore, it is very clear, although there's energy loss, there is no external force, external unbalanced force exerted on the system. As there is no external unbalanced force exerted on the system, the total momentum will not be changed. It will not be changed. But due to this reason, some energy can be reduced. Therefore, if you are given this kind of system, it is very clear you can use linear momentum conservation to evaluate the system. But you cannot use energy conservation as there is an energy loss due to the collision. Is that clear? If you got that one, please raise the hand. If you got that one, please raise the hand. I need responses from everyone. Sasindu, Sukuma, Devanuti, hello, this is what they're doing. Sasindu. Therefore, during an inelastic collision, so this is inelastic collision, Pute. Therefore, during an inelastic collision, inelastic collision, elastic, inelastic, and the momentum is okay. Energy loss due to recover. Pute, now there are some objects, Pute, those are very rigid objects. Something like metal balls, they are very rigid objects. Therefore, during collisions, actually they will not deform. They will not deform. If there's a deformation, that is very, very small deformation that can be neglected. And therefore, if the object is very hard object, something like metal ball, then we cannot observe a deformation. Therefore, during elastic collision, okay, so there's a contact okay, that may stage is there, this stage is there, but the second stage there is no deformation, no deformation, okay. No deformation. No deformation. Therefore, if you can say about elastic collision, we can use make the linear momentum conservation as well as energy conservation because both are conserved. Elastic collision, therefore, linear momentum conservation can be used. Getting the energy conservation. Can be used. Therefore, both linear momentum and energy conservation can be used for them. So that is the difference between elastic and inelastic collisions. Did you get that one? If you got that one, please raise the hand. Make a hurried metal balls one. Make a rubber ball. The metal ball like deformation and rubber ball like rubber ball like politics deform. Rubber ball. Metal balls, sorry. Due to the rigidity of that body, there's no deformation. So after the collision, actually they will bounce. Bounce means they will not stick together, and after the collision they will move along with it. And therefore they will not stick together, they will bounce and they will move along with different velocities. Inelastic. Sorry, inelastic. ඒක perfect inelastic වෙනවා. ඊළඟට අපි ඒක මම කතා කරමු. හරි. Therefore, after the collision, they will move with different velocities. मेरे U के लिए U1, U2, में bounce. Bounce means not stick together. Bounce means not stick together. Now we can take the third case. Perfectly inelastic collision. Perfectly inelastic collision. Put in perfect inelastic collision. In perfect inelastic collision, after the collision, both objects will move together. Move together because in perfectly inelastic collision, the kinetic energy loss will be maximum. There is maximum kinetic energy loss during a perfectly inelastic collision. That maximum kinetic energy loss may be the entire kinetic energy loss. That means entire kinetic energy will be lost. And in such cases, after collisions, both objects will be stick together and may not move anywhere. And something like clay ball. So if you throw a clay ball to the floor, what will happen? So after the collision between floor and the clay ball, both will stick together and may stay at the rest condition. That means the entire kinetic energy will be lost. And therefore, in perfectly inelastic collision, the kinetic energy loss will be maximum. Maximum means not entire. Sometimes it may be entire loss. Sometimes it may be a maximal loss, but not entire. So how to identify whether there is a maximum kinetic energy loss or not? How to identify that one? To identify that one, we can observe the motion of two objects after the collision. So after the collision, if they move together, if they stick together and move as a combined object, then definitely there will be a maximum kinetic energy loss. Maximum kinetic energy loss. And Okay. මම ගොඩක් වෙලා මේ ස්ක්‍රීන් එක උදේ කතා කරා. මම දැක්කේ නෑ මම ගෑම්මක දිහා බලාගෙන කතා කරේ. මම දැක්කේ නෑ ස්ක්‍රීන් එක ඔෆ් වෙලා. ඒක මට චාර්ජර් ඔන් කරන්න බැරිලා චාර්ජර් ගහලා තිබ්බ චාර්ජ් එක ඔන් කරන්න බැරි. හරි. මේ ටික විශ්වාසද? Okay, I will explain that is again today. ඇහනව නේද? ඇහනව නේද? Okay, thank you. Very good. Okay, so what is the perfect inelastic collisions mean today? Perfect inelastic collisions means if during the collision, if the kinetic energy loss is maximum, during the collision, if the kinetic energy loss is maximum, then such kind of collisions are called perfectly inelastic collisions. And as I told you earlier, kinetic energy loss is maximum means sometimes it may be a fully kinetic energy loss. Sometimes it may not be fully kinetic energy loss, but that is the maximum kinetic energy loss for that particular case. And so as I explained you earlier, if you throw a clay ball onto a floor, definitely kinetic energy will be fully lost. Therefore, it is a perfectly inelastic collision because there is a maximum kinetic energy loss. But after the collision, if there is a motion of two objects with maximum kinetic energy lost, then definitely they will move together as a combined object. They will move together as a combined object. This can be proven when you are doing this unit in combined maths. So then with the combined maths, prove කරන්න පුළුවන්. මොකද මේක prove කරනවා නම් පුංචි දේවල් ටිකක් ඕනේ. ඒක විතර මේ බයෝ කරන එකක් ඇති නිසා ඒක explain කරන්න අවශ්‍ය නැහැ. හැබැයි මෙහෙම දෙයක් තියෙනවා හදලා තියාගන්න. මෙතන අපි බලන්න ඕනේ kinetic energy loss එක maximum වෙන විදිහ. kinetic energy loss එක maximum වෙන්නේ මොන වගේ මොකද කියන එකයි බලන්න. හරි. kinetic energy loss එක maximum වෙනවා නම් අනිවාර්යෙන් මේ දෙන්නම එකට යන්න. හරි. Okay. Therefore, during the collision, definitely there is no any external unbalanced force. But after the collision, kinetic energy will be lost at its maximum value. Therefore, you can use linear momentum conservation for this kind of collision, but energy conservation cannot be used. Therefore, linear momentum conservation can be used. Energy conservation cannot be used. Perfect elastic කියලා කතන්දරේ පුතේ මේ අපි ඔය maths වලදී අපි use කරන ඒ වචනේ දැන් මේක මෙතන අපි elastic කියන කතන්දරේ perfect elastic කියන කතන්දරේ දෙකම එකයි. ඒක වෙනසක් නෑ. මොකද අත්තම කතන්දරේ කියනවා නම් අපි maths කතන්දරේ කතා කරපුදී අත්‍තරම කියනවා නම් තියෙන්න පුළුවන් මේ අවස්ථා තුන විතරයි. ඒ කියන්නේ move perfectly කියන්නේ perfectly elastic අවස්ථාව ඊළඟට perfectly inelastic අවස්ථාව දෙක අතරම අවස්ථාව. තියෙන්න පුළුවන් මේ actually there should be three stages අතමුතේ. The one is if there's no energy lost. If there's no energy loss, that is the one case. The lower case means if there's a maximum energy loss, then there should be intermediate, only intermediate one case. That means if there's an energy loss, but it is not maximum. And therefore, there are only three cases. So if there's no energy loss, it will be called as elastic. So perfect elastic means elastic. Perfect elastic means elastic matama. Have දෙකම එකයි. Perfect elastic වත් එකයි elastic වත් එකයි දෙකම එකයි. හරි. අර මේ අර සමහරවල් අර මැත්සෝදී අපි ගොඩක් වෙලාවට ඒක යූස් කරනවා. මොකද අර perfect elastic කියන ඒ කියන්නේ ටර්ම් එකක් විතරයි යූස් කරන්නේ. හරි. දෙකම එකයි. inelastic කියලා කියන්නේ එතකොට අනිවාර්යෙන් එතන energy loss එකක් තියෙනවා. Perfectly elastic කියලා කියන්නේ energy loss එක maximum. Right? Okay. So if there's a perfectly elastic collision puti, after the collision, both objects will stick together and move it as a combined object. Moves as a combined object. Stick together after the collision. ඊළඟට linear momentum conservation. Energy conservation. Right. If we consider about elastic collision, elastic or perfect elastic, both are correct. Elastic collision, linear momentum conservation can be used as well as energy conservation. Both can be used. Both can be used. If we consider about inelastic collision, linear momentum can be used, but there is energy reduction during the collision. Therefore, energy conservation cannot be used. Perfect inelastic collision, the same thing. Linear momentum conservation can be used, but no energy conservation. There was some kinetic energy will be lost. Here, maximum kinetic energy loss. Okay. Did you get that thing? Hey, okay. The right topic. Characteristic of elastic within the bracket perfectly elastic close bracket, inelastic and perfectly inelastic collisions. Inelastic and perfectly inelastic collisions. That is the topic. Characteristic of elastic within the bracket perfectly elastic close bracket, inelastic and perfectly inelastic collisions. Okay, that is the topic. Then draw this table and write up to this. Have I finished with it? Have I finished? No. Have it. No, no, no. After this. All the things. Hi. Okay, please listen to me. මේක අඳිනකම් පොඩ්ඩක් මේක පොඩ්ඩක් මේ පොඩ්ඩක් නවත්තන්න. පොඩ්ඩක් අහගන්න මම කියන්නේ. හරි. පුතේ දැන් ඕගොල්ලෝ දැකලා තියෙන ඔය පොලිෂන්ස් ගත්තොත් එහෙම ඇක්චුවලි මේ ඕගොල්ලෝ මේ දැකලා ඇති සාමාන්‍යයෙන් කොලිට් වුණාට පස්සේ සමහර ඒවා බවුන්ස් වෙනවා. සමහර ඒවා ස්ටික් වෙලා දිගටම යනවා. නේද? කොලිට් වුණාට පස්සේ දැන් අපි ගත්තොත් එහෙම නිකන් උදාහරණයක් ගන්න අපි එක්සැම්පල් එකක් ගන්න අපි ඇක්සිඩන්ට් එකක් ගන්න. වාහන දෙකක් ඇක්සිඩන්ට් වුණාට පස්සේ සමහර වෙලාවට ඇක්සිඩන්ට් වුණාට පස්සේ වාහන දෙක දෙපැත්තට යනවා. සමහර වෙලාවට ඇක්සිඩන්ට් එකෙන් පස්සේ වාහන දෙක එහෙම යන්නේ දෙක ස්ටික් වෙලා තියෙනවා. ස්ටික් වෙලා තමයි දෙන්නම එක තමයි යන්නේ. හරි. දැන් එතකොට එහෙනම් අපි දැනගන්න ඕනේ ඔය කොලිෂන්ස් ගත්තොත් එහෙම කොලිෂන් අර වෙන පැටර්න් එකත් එක්ක කියන්නේ වෙන පැටර්න් එකත් එක්ක ගත්තොත් එහෙම කොලිෂන්ස් අපිට මේන්ලි ඔන්න ඔය කියන ටයිප් දෙක දාන්න පුළුවන්. ඒ කියන්නේ කොලිෂන් එකකින් පස්සේ මේ ස්ටික් වෙලා මේ යන්නේම අනිත් එක ස්ටික් වෙලා යන්නේ නැති අවස්ථා කියලා. පැහැදිලිද? දැන් අපි ගත්තොත් එහෙනම් පුතේ if you consider about elasticity means uh, actually it is something like restore the original position පුතේ. Elasticity means when we apply a force it will deform. So after releasing that force it will come to the original position. So that is the meaning of elasticity. Therefore during elastic collision its original shape will not be changed. This original shape will not be changed, it will remain as a constant. But if there's an inelastic collision its shape can මට තව කොලම් එකක් දාන්න තිබ්බ අපරාධ මට කවුද උන මෙතන shape එක කවන්නේ දැන් කවන්නේ මම ඉන්සර්ට් කරන්න එක තියෙනවා. දැන් මෙතනදී මොකද වෙන්නේ? Here its original shape can be changed, but the objects try to restore that deformed shape to the original shape. They try to restore. Therefore, it will consume some energy to restore. Sometimes it will restore, sometimes it may not be restored, but it will consume some energy to restore. So in such cases, definitely it will consume some energy. Then here now after the collision, what will happen? They will deform, not only deform, they will not come to the original position at any case, because both objects will move together after the collision. That means they will never come to the original position. Therefore, in such collisions are called perfectly inelastic, because elasticity is totally out. They will never come back to the original shape. That is the physics explanation today. So what are the examples for perfectly inelastic collisions? Are accidents ගත්තොත් එහෙම වෙනවා සර්. ඒ සාමාන්‍යයෙන් අපි ගත්තොත් එහෙම මේ මොනවද අපි ඔය කොලිට් වෙනවා මේවා තියෙන්නේ ස්පොට්ස් තියෙන්නේ රගර් එහෙම ගන්නකො දැන් රගර් එකක් කියන රගර් ගත්තොත් එහෙම අපි මේ ඔය බෝරල පොර කරනකොට එක්කෙනෙක් ඇඟට පැනලා කිලින්ම ඌත් එක්ක බලන්න පුතේ කිලින්ම අය කොලිට් වුණාට පස්සේ දෙන්නත් එක්කම යන්නේ. හරිද? ඒ වගේ දැන් ඒ වගේ කොලිෂන්ස් තව මොනවද? හ්ම්. අපි දෙන්නත් එක්කම ඒ කියන්නේ දැන් අපි ගත්තොත් එහෙම මොකක් හරි මේක අකර වෙඩිල්ලක් වගේ අකර මොකක් හරි දෙයක් ගිහිල්ලා මොකක් හරි ඔබ්ජෙක්ට් එකක වදිනවා ඊට පස්සේ ඔබ්ජෙක්ට් එකයි වෙඩිල්ල ඒ මේ බුලට් එකයි දෙකම එකට යනවා දෙකම එකට යනවා ඒ වගේ තමයි හරි ඒ වගේ කියන්නේ කොලිෂන් එකෙන් පස්සේ ආයෙ පාරක් මේගොල්ලෝ එකටම යනවා නම් අපි ඒවට කියනවා perfectly elastic කියලා perfectly elastic හරි හරි මම මේක පොඩ්ඩක් පැහැදිලි කරන්න කොහොමද මැක්ස්වෙල් කොහොමද මේ ප්‍රූව් කරන්න කියලා. ඒක ඇඩිෂනල් කතන්දරයක්. ඒක ඕනේ නැහැ හොඳ ෆිසික්ස් වලට. Okay. Yeah. නෑ පුතේ නෑ රබර් බෝල් එකකින් ඉලාස්ටික් වුණා කියලා රබර් බෝල් එකකින් ඉලාස්ටික් නෙමෙයි කොලිෂන් එකකින් ඉලාස්ටික් කියලා කියන්නේ. කොලිෂන් එකකින් ඉලාස්ටික් කියලා කියන්නේ කොලිෂන් එකේ අර එනර්ජි ලොස් එකක් තියෙනවා නම් තමයි කොලිෂන් එකකින් ඉලාස්ටික් කියලා කියන්නේ. හරි. ඉලාස්ටිසිටියයි මේකයි පටලවා ගන්න එපා. හරිද? ඉන්ඉලාස්ටික් කියලා කියන්නේ එනර්ජි ලොස් එකක් තියෙනවා නම් තමයි ඉන්ඉලාස්ටික් කියන්නේ. ඒ එනර්ජි ලොස් එකක් තියෙන්නේ එයාට එයාගේ රබර් බෝල් එකේ අර ඉලාස්ටික් ප්‍රොපර්ටි එක නිසා තමයි එයාට ඉන්ඉලාස්ටික් කොලිෂන් එකක් වෙන්නේ. හරි. ඒ රබර් බෝල් එකේ තියෙන ඉලාස්ටික් ප්‍රොපර්ටි එක නිසා එයා ඔරිජිනල් ෂේප් එකට එන්න try කරනවා. ඒ එන්න try කරන්නේ එයාට එනර්ජි එකක් ඕන. ඒ එනර්ජි එක එයාගේ කලින් තිබ්බ කයිනටික් එනර්ජි එකෙන් අරගන්න. ඒක නිසා තමයි කොලිෂන් එකේ ඉලාස්ටික් වෙන්නේ. හරි. කොලිෂන් එකේ ඉලාස්ටික් කියන්නේ එක කතන්දරයක්. කොලිෂන් එකේ ඉලාස්ටික් කියලා කියන්නේ තනිකරම කයිනටික් එනර්ජි එක කන්සර්ව්ද නැද්ද කියන එක මත තමයි ඩිපෙන්ඩන්ට්. හරිද? කොලිෂන් එකේ ඉලාස්ටික් කියන කතන්දරේ ෂේප් එකට අදාළ දෙයක් නෙමෙයි. හැබැයි ෂේප් එක අදාළයි ෂේප් එක රීස්ටෝර් කරන්න යන එක නිසා තමයි එනර්ජි ලොස් එකක් වෙන්නේ. ෂේප් එක රීස්ටෝර් කරන්න යන නිසා එනර්ජි ලොස් එකක් වෙනවා. එනර්ජි ලොස් එකක් තියෙන වෙලාවක අපි කියනවා ඒක ඉලාස්ටික් කියලා. එනර්ජි ලොස් එකක් නැත්නම් අපිට ඉලාස්ටික් කියලා කියනවා. ඒක just a word පුතේ. හරි. ඉලාස්ටිසිටි කියන එකයි මේ ඉලාස්ටිසිටි කියන්නේ වෙන කතන්දරයක්. ඒක වෙනම කතන්දරයක්. හරි ඉලාස්ටිසිටි කියන එකයි මේක දෙකක්. ඉලාස්ටික් කොලිෂන් කියන එකයි ඉලාස්ටිසිටි කියන එකයි දෙකක් හොඳේ. ඒක පටලවා ගන්න එපා. හරි. තේරෙනවද? ඉලාස්ටිසිටි කියන එක එකක්. ඒක තමයි අර කොහොල කිව්වරක මොකක් හරි ඩිෆෝම් වුණාට පස්සේ ආයසරක් මේ ඩිෆෝම් වෙච්ච එක ආයසර රිස්ටෝර් වෙන එක තමයි ඒක ඉලාස්ටිසිටි එක. ඒක හරියි. හරිද? ඒ ඉලාස්ටිසිටි. ඉලාස්ටිසිටි කියන එකයි ඉලාස්ටික් කොලිෂන් කියන එකයි වර්ඩ්ස් දෙකක් පුතුනේ. 되게 나갔었다. Okay, have you finished? Have you finished? Okay, they write on this. Write on this as a special note. Special note ಟಾಗಿ ನಿಮಗೆ ಏನಾಗುತ್ತೆ? Special note ಟಾಗಿ elasticity and elasticity and elasticity and elastic collisions are two different technical terms. Elasticity and elastic collisions are two different technical terms. Elastic, inelastic collisions, elastic, inelastic collisions depend on kinetic energy loss during the collision. Have a look at it. Okay. Write this question. Write this question. Question number one. Question number one. Question number one. 2 kg mass, 2 kg mass, and sorry, a 2 kg mass, and a 3 kg mass move towards the each other, on a smooth horizontal floor, on a smooth horizontal floor, on a smooth horizontal floor, at a speed of 6 ms minus 1 and 4 ms minus 1 respectively. After the collision, after the collision, after the collision, 2 kg mass, 2 kg mass, moves into the backward direction, moves into the backward direction at a speed of 4.5 ms minus 1. At a speed of 4.5 ms minus 1. Number 1 to 3. First question. Find the velocity of 3 kg mass. Find the velocity of 3 kg mass after the collision. Number 2. Determine the category of this collision. Determine the category of this collision. Second question. Second question. A bullet with 20 gram mass. A bullet with 20 gram mass . strikes a bullet with 20-gram mass, strikes 10 kg object, 10 kg object, which is on a rough horizontal surface, 10 kg object, which is on a rough horizontal surface, full stop. The initial speed of the bullet, is 50 ms minus 1. The initial speed of the bullet is 50 ms minus 1. And it will rebounds. It will bounce back. It will bounce back. It will bounce back it will bounce back at a speed of 15 ms minus 1. 15 ms minus 1 after the collision. First question है there. First question. Find the velocity of 10 kg mass. Find the velocity of 10 kg mass just after the collision. Find the velocity of 10 kg mass just after the collision. Number 2, if the 10 kg mass moves 1.5 meter on the rough surface, before it comes to rest. Before it comes to rest, tamam. Find the friction force. Find the friction force exerted by the horizontal flow. Find the friction force exerted by the horizontal flow. Third one, determine the coefficient of dynamic friction. Determine the coefficient of dynamic friction between the flow and 10 kg mass. Determine the coefficient of dynamic friction between the flow and 10 kg mass. Suruskala kan. What do you Okay, have finished. Have finished. If you completed 2 questions, please raise the hand. And first question First question. Yeah. Shall I look into the first question? Okay, now there are 2 kg and sorry, that's 2 kg and 3 kg mass. Here 2 kg mass and 3 kg mass. Okay. So now I can draw 2 stages for the 2 occasions. First occasion is before the collision, then after the collision. So before the collision, they move towards each other at a speed of 6 and 4. 6 ms minus 1 and 4 ms minus 1. Then they collide. So after the collision, 2 kg mass moves towards the backward direction at a speed of 4.5 ms minus 1. Now you are asked to determine the velocity of 3 kg mass. So I don't know velocity where velocity is, but then I will assume the velocity is in this direction and it is v. Okay. Then I can determine v with direction and magnitude. So if it is negative, that means my assumed direction is wrong. It will be into the other side. Anyway, shall we go? Okay, so if there's any collision, we can use linear momentum conservation because during the collision, although there is impulsive forces, they are equal in magnitude and opposite in direction. Therefore, there's no any external force. Therefore, I can use linear momentum conservation. Then, so if I use linear momentum conservation for the entire system, you have to write what is the object you are going to consider. When you are applying linear momentum conservation, definitely you have to write what is the object that you are going to consider. So here you are going to consider the entire system, linear momentum conservation for the system. And then you need to mention the direction. That means you are going to consider the linear momentum of the system into this direction. So when you are applying linear momentum conservation, you have to mention the object that you are going to consider, object or entire system, and then the direction. Okay, now you have to write the momentum of the system into this direction. Momentum of the system into this direction. Initially, momentum of the system is system. Now the system has 2 masses. One is 2 kg mass, other one is 3 kg mass. Initially, 2 kg mass moves into this direction, 3 kg mass moves into this direction. Therefore, initially, there is a momentum by 2 kg mass, that is 2 into 6, that is into this direction. Then 3 into 4 momentum, but that is into other direction. Okay, therefore that is minus 3 into 4 is equal to this direction. It will be therefore 3 into V, that is positive. This one is negative. Okay. So 3 into V into this direction, and 2 into 4.5, 2 into 4.5 into other direction, that means that is minus. So that is the entire momentum of the system. Okay. If you got this one, please trace that. Make it. So this is the entire momentum initially in the first case. This is the entire momentum after the collision. If you got that one, please raise the hand. Now I can simplify with it. Make a 0. Make a 0 and make a cancel out 1.5. And V is equal 3 ms minus 1 into right hand side. You have mentioned the direction too. Make our Tusan. If you got this answer, please raise the hand. Okay. Then you need to determine what is the type of this collision. Actually, the categorization of collisions are done based on the energy loss. Therefore, to categorize the collision, you need to determine the energy, initial energy, and the final energy of the system. Then you can determine whether there is energy loss or not. Okay. Then the initial energy, initial kinetic energy of the system, initial kinetic energy of the system. So that is equal half mv square. It means 2 into v square means 36 plus m into v square means 60. Therefore, initially energy is method make it 8 2 24 plus 36 means 60 joule. Initial kinetic energy of the system was 60 joule. Then final kinetic energy of the system. Kinetic energy system final. M is 2 into 4.5. Sorry, 4.5, 4.5 into 4.5. Plus 3 into 9. 3 into 9. Sorry. මෙතන එනවා පුතේ එතකොට නේද ඉස්සයිස් පහ විකිරීම දෙක කියලා කියන්නේ 45. Therefore, answer is 33.752. 33.752. Negative 33.752. Did you get this answer? Now, initial kinetic energy was 60 joule. Now after the collision, the kinetic energy is 33.75 joule. That means there is a energy lost during the collision. But so after the collision, the object actually they are not stick together with it. Therefore, this is not a perfectly inelastic collision, but this is an inelastic collision. This is an inelastic collision because there is an energy loss, but objects are not moving together. Therefore, this is not a perfect inelastic, but it is an elastic. It is inelastic. Okay, therefore, there is an energy loss, but masses not stick together. Therefore, this is an inelastic collision. Therefore, this is an inelastic collision. If you got my explanation, please raise the hand. Mangatate argument theorana tusan. May I say that is a theorana tusan? බලන්න පුතේ මෙතන එනර්ජි ලොස් එකක් තියෙනවා එනර්ජි ලොස් එකක් තියෙනවා මේක කවදාවත් ඉලාස්ටික් වෙන්න බෑ හරි එහෙනම් එක්ක මේක ඉන්ඉලාස්ටික් නැත්නම් පර්ෆෙක්ට්ලි ඉන්ඉලාස්ටික් වෙන්න පර්ෆෙක්ට්ලි ඉන්ඉලාස්ටික් වෙන්න බෑ මොකද මේගොල්ලෝ ස්ටික් මේ කියන්නේ කොලිෂන් එකෙන් පස්සේ මේගොල්ලෝ මේ කියන්නේ එක්කෙනෙක්ට මේ පැත්තට මේ වෙලොසිටි තියෙනවා අනිත් එක අනිත් පැත්තට වෙලොසිටි එතන එකට යන්නේ නැහැ therefore there should be inelastic collision just an inelastic collision. Okay. Then do the question number 2. May I tell you now? May I tell you now? Thank you, then. Okay. Please go through the next question. හරිද? මොකද ඒ? හදලා ඉවරද අරක? question number 2. Okay, now there's a 10 kg mass to it. Now, a bullet with 20 gram නේ. a bullet with 20 gram කියලා දෙනවා දුන්නේ. 20 gram එකක් දුන්නේ. Comes at a speed of 50 ms minus 1 and hit with this one. Then, after the collision, this bullet bounced back at a speed of 15 ms minus 1. Okay. Now this is a rough surface. So after the collision, this object will have some kinetic that means velocity. Then it will move 1.5 meters. (1.5 meter) along this rough surface before it comes to the rest condition. Right. Now, the first question was, what is the velocity of 10 kg mass just after the collision? Just after the collision. Now tell me, can you apply linear momentum conservation for this collision? Can you apply? Listen. Gandhi. Can you apply? Rasid? What is your opinion? Can you apply linear momentum conservation for this one? Shashmita? Can you apply linear momentum conservation for this collision? Can. Okay. But this is a rough surface, no? So that meaning there may be some friction force also. Therefore, it is an external force. So how can you apply linear momentum conservation? Huh? Now, this object is on a rough surface, no? So as this object is on a rough surface, definitely there is a friction force, no? Therefore, how can you apply linear momentum conservation for this subject? කොහොමද apply කරන්නේ? මම හොඳට තේරුම් කරගන්න ඕනේ දේවල්. ඩීනත්? රශ්මිද? ආලසත් කොහොමද apply කරන්නේ? ඒක හිතුවේ නැද්ද? consider කරේ නැද්ද friction එක? නැත්නම් ඒක අමතක වුණාද? linear momentum conservation. Can be or cannot be. So, what is your explanation? Now, this object is on a rough surface, then definitely there will be a friction force put it. So, definitely momentum can be changed. How to apply it? Put initially, this object was in rest condition. Therefore, although the object was in a rough surface, there is no external friction force exerted on that object, Pute, because that is on a rest condition. Ne? Yes, for this. Therefore, although the object is on a rough surface, there's no friction force exerted on that object, Pute. Therefore, you can apply linear momentum conservation. On the other hand, you are asked to determine the velocity just after the collision. Just after the collision means we can consider that one as just before the movement through the rough surface. Just before the movement through the rough surface, because once the object moves through the rough surface, then definitely velocity decreases. As you are asked to determine the velocity just after the collision, that means there is no friction exerted on the system, because the object initially was rest condition, therefore no friction here. Just after the collision, you need to determine the friction, you need to determine the velocity just after the collision. Therefore, you can consider that one as the velocity just before the starting of motion. And take up it, consider a node name. That is the reason. You can note down the thing. Write this one as a note, this special note. Although the object was on a rough surface. Although the object was on a rough surface, it was at rest. It was at rest. Although the object was on a rough surface, it was at rest. Therefore, no friction force is exerted. No friction force is exerted at the beginning of the motion. At the beginning of the motion. Therefore, we can apply linear momentum conservation for this collision. Therefore, we can apply linear momentum conservation for this collision. And linear momentum conservation to the system in this direction. Then initial that's a speed with 20 gram. 1 gram body maganda easy. 20 gram into 50. Here initially it was 0 and finally 10 kg mass means 10 kg means 10,000 gram into V minus minus 20 into 50. 20 into 50. You can take this one into here. Therefore, V is equal 20 into 65 over 10,000. මේකට මේ කියනවා පුතේ මේකට CI හින්දුවක් මහත්මයි CI MS minus 1. So this is V. It means V is equal 0.13 MS minus 1 to this direction. If you got this answer, please raise the hand. Maybe I want to question. Only one student. Shashmidu, what is that? Two. Yeah. Anita, Tarada. Okay. Thank you. No. If the object is in motion on a rough surface, we cannot apply. And so if it is moving in smooth surface, it doesn't matter. But if the object moves in a rough surface, we cannot apply linear momentum conservation because now it is already external force is there. Therefore, momentum cannot be conserved. Momentum cannot be conserved. Definitely, due to the external force, definitely momentum can be changed. And then, second one. Second one. Now this object moves 1.5 meter. 1.5 meter. Yes, 1.5, no? 1.5. 1.5 meter distance to this rough surface. You are asked to determine the frictional force within. Suppose now there's friction force within. How to determine friction force? Can anyone tell me how to determine the friction force? Again. How to determine the friction force? Gandhi? How to determine the friction force? Listen. No. How to apply F equal ME? Yes. There is one correct one. You have determined acceleration, no? Then you can find it. Yes, very good listen. Very good listen. That is the easiest way. That is the easiest way. You know, now we have done energy conservation. We have done energy conservation. Therefore, initially this object has a kinetic energy. Initially, this object has a kinetic energy. So, using the kinetic energy, this object will do a work against friction until the total energy is lost. Therefore, the work done against friction, the work done by this object against friction is equal to the entire kinetic energy, because the entire kinetic energy is lost due to the work done against friction. Therefore, kinetic energy of object is equal work done against friction putih. Work done against friction. Because total kinetic energy is lost due to this work done. If you got my argument, please raise the hand. Make the understand my argument. Therefore, kinetic energy of the object is equal half m can put a 10, v can make that means 1.69. 1.69 is equal work done against friction. That means Fs. F into S means 1.5 meter. 1.5 meter. Make a 3 putih. Therefore, F is equal friction force is equal 16.9 over 3. Therefore, here for height 5.6 Newton. 5.6 Newton. මම මෙතන මේක කරලා වැරදිනේ. v squared අරන් වැරදි. sorry sir. v squared අරන් වැරදි. v squared ගත්තාම පුතේ 4ක් එනවානේ. ඉතින් 0.0169. 0.0169. sorry. ඒ කියන්නේ 169 169. එතන තව එන්නෝනේ 0.169. 0.169 over 3. And 0.056 Newton. 0.056 Newton. And then you have to determine the mu. Mu means coefficient of friction. Coefficient of friction. So coefficient of friction can be determined using F equal mu R. Therefore, mu means F over R. F means 0.056. Now R is 100 Newton. R is 100 Newton. Here R 100 Newton. So R is equal 100 Newton. R is equal 100 Newton. Therefore, mu is 0.00056. 0.00056. මේක ආවද අතොස්සන්? If you got these answers, please raise the hand. You too. Okay, then write this question. Question number three. Question number three. Question number three. Two clay balls. Two clay balls only. Two clay balls of 0.5 kg. 0.5 kg and 0.25 kg. 0.5 kg and 0.25 kg are moving towards each other. Are moving towards each other. Are moving towards each other at a speed of 4 ms minus 1 and 3 ms minus 1 respectively. That is at a speed of 4 ms minus 1 and 3 ms minus 1 respectively. If they stick together, move as a single object, move as a single object after the collision, find the velocity of the composite object. Find the velocity of the composite object and determine the kinetic energy reduction. Determine the kinetic energy reduction of the system. Determine the kinetic energy reduction of the system. Okay. Tak jalan. Mm. Mm. Okay, Balapati, third question. Now there are two cables. That means definitely this is an elastic, inelastic, or perfectly elastic collision. Perfectly elastic collision. 0.5 kg mass moves at a speed of 0.43. 5 is minus 1. Then 0.25 kg mass moves at a speed of 3 is minus 1. So after the collision, they will stick together and this combined object moves at a certain speed. Now combined object has a mass of 0.75 kg. Okay. So I cannot apply energy conservation, but I can apply linear momentum conservation. Therefore, I can apply linear momentum conservation to the system in this direction. Okay. Initial momentum of the system is 4 into 0.5 and minus this momentum is to other side of the thing. 3 into 0.25 is equal. The final momentum is into the same direction as positive. That is equal 0.75 into V. Therefore, දෙකයි දෙකින් අයින් කරන්න ඕනි 0.75. Again 1.25. 1.25 0.75. Therefore, V is equal within 5 over 3. That means 1.67 ms minus 1. 1.67 ms minus 1. So this is the final velocity of the system. That is into the chosen direction. Now the kinetic energy loss. Kinetic energy loss. That means kinetic energy difference. Kinetic energy difference means initial kinetic energy minus final kinetic energy. Initial kinetic energy mv square. Mv square means m means 0.5. V square means 16. Here m is 0.25. V square means 9. That is the initial kinetic energy minus final kinetic energy. Minus final kinetic energy means a half. M is 0.75 into V means 5 over 3. 5 over 3. Now that whether I mean attack, whether you know attack at with again the petitioner, they can show the paper, they can show the paper. With an attack the hand show the paper. Utara 3 or 4. They can mean 5 over 1.25 minus 1.25 over 2. Therefore, answer is within 1.25 9. 9 over 2 means 4.52. 4.52. Method of 3 over 4. 3 over 4, 3 will be cancelled out. 5 over 4 can 1.25. 1.25 over 2 can make it. Method attack 9 over 4 can put 2.25. Again 10.25. 10.25 minus 1.25 can 9. 9 over 2 can 4.5. Okay. If you got this answer, please raise your hand. Okay. Shall I erase? Shall I erase? मैं तेरना दूसरा बते मैं हाथ पे तेरना दूसरा. If you got my calculation, please raise the hand. Okay, thank you. Okay. Hello, buddy. Okay. Then write topic. Write topic. One dimensional elastic collisions. One dimensional elastic collision. This is a topic. This is very, very important topic. One dimensional elastic collisions. Now we are discussing about, we are going to discuss about elastic collisions. Elastic collisions, one dimension. With a one-dimensional collisions means if the collisions is occurred linearly, then we call the such kind of collisions as one-dimensional collisions. One-dimensional collision because we can measure the distance into only one direction. The distance can be measured into one direction only. Therefore, such kind of collisions are called as one-dimensional collisions. One-dimensional collision. Elastic collisions. One-dimensional elastic collisions. Okay. Suppose now there are two masses. One is M1 moving at a speed of U1, collide with another mass M2 moves at a speed of U2. So after this collision, so M1 object moves at a speed of V1, M2 moves at a speed of V2. Right? Okay. Now we can apply equation for this motion puthe or collision. So you know now this is a elastic collision puthe. So as this is a elastic collision, actually we can apply two relationship. One is linear momentum conservation. The second thing is energy conservation because both are conservative. And because this is elastic collision. So as this is elastic collision, as this is an elastic collision, both the linear momentum and kinetic energy are conserved. Right. Then I can write linear momentum conservation puthe for the system to this direction. Then I can write initial momentum is equal m1 u1 plus m2 u2 is equal m1 u1 plus m2 u2 is equal final momentum to that direction is m1 v1 plus m2 v2. Okay. If you got my argument, please raise the hand. එක තේරුණා තුෂ්ෂන්. එක තේරුණා තුෂ්ෂන්. මම මේ ගත්ත එක තේරුණා තුෂ්ෂන් උතේ. If you need any explanation, please give me a comment. ආයි මොන නමට කියන්නේ? It is better to give a response from each student today because I need to know whether you can understand the thing or not. And very well understand කරන්න බැන්න මට කියන්න මම ඇස්ස එක explain කරන්න. නැත්තම් මත් යනවා. හරි. Okay. Now I can bring M1 terms into this side, M2 terms into that side. Therefore, if I bring M1 terms, then I didn't get you with it. How the collision is accomplished? But then how the question is? How the collision is accomplished? Oh. ඇයි දැකලා නැද්ද පිටිපස්සෙන් වාහන ඇවිල්ලා හැප්පෙනවා ඈ පස්සෙන් ඇවිල්ලා හැප්පෙනවා දැකලා නැද්ද ඈ මගේ නම් තාමත් තියෙනවා පස්සෙන් ඇවිල්ලා හැප්පෙනවා පස්සෙන් ඇවිල්ලා හැප්පෙනවා දැකලා නැද්ද ඈ එදී ඉස්සරහට එක හිමියනවා බැරි වෙලා හරි බ්‍රේක් එකක් ගියොත් පිටිපස්සෙන් ගිහලා හැප්පෙනවා ඈ වෙන්න පුළුවන්ද මේකගේ ස්පීඩ් එක අඩු නම් මොකද ස්පීඩ් එක වැඩි නම් ඈ මොකද ස්පීඩ් එක අඩු වෙනවා මොකද ස්පීඩ් එක වැඩි නම් මොකද වෙන්නේ ඈ එන පිටිපස්සේ එකක් ගිහලා හප්පලා යනවා පැහැදිලිද කොලිෂන් එකක් එන්න මේ කියන්නේ මෙහෙම වෙන්න යන්න ඕනේ නැහැ එකම පැත්තට ඉහළ කොලිට් එක තමයි ඕන තරම් මේ vehicles වෙන්නේ ඕන තරම් එකම පැත්තට ඉහළ කොලිට් එක අර හයිවේ එකේ නැත්තම් කොහොමද ඒක මේවා වෙන්නේ හයිවේ එකේ වෙනදනක් එන්නේ එකම පැත්තට දෙපැත්තට ගිහලා හැප්පෙන්න බෑ නේ එකම පැත්තට ගිහලා හැප්පෙන්නේ කාගේ හරි ස්පීඩ් එක වෙනස් වෙච්ච එකම අනිත් එකගේ ස්පීඩ් එක වැඩි නම් අනිවාර්යෙන් ගිහලා හැප්පෙනවා අනිත් එක්කෙනා කියන්නේ පිටිපස්සේ එක්කෙනාගේ ස්පීඩ් එක වැඩි වෙනවා පිටිපස්සේ එක්කෙනාගේ ස්පීඩ් එක අනිවාර්යෙන් වැඩි වෙනවා And so if the speed of the object moves in backward, moves secondly, then definitely they will collect something. Then M1, you have to take M1 part to this side, then M1 into U1 minus V1 is equal, you have to take M2 terms to other side, N2 is equal V2 minus U2. Yeah. Then, this is first one, but then I can apply energy conservation law. So if I apply energy conservation law for the entire system, initial kinetic energy is half M1 U1 square plus half M2 U2 square is equal. Final kinetic energy is half M1 U1 square plus half M2 V2 square. So if you are given a question in essay paper, if you are given a question in essay paper, you have to apply these two relationship and get the answers to it. So that is the standard arguments. But most of the cases we are given this kind of question in MCQ paper. Therefore, we have to have short methods to calculate the final velocities. And so actually, if we are given a one-dimensional elastic collision in essay paper, you cannot use the short methods, but you have to go through the fundamental arguments with it. But most of the cases, those kind of questions are in MCQ paper with it. Therefore, we need to have some short methods to calculate final velocities. Now, I'm going to do that thing. And look at this one. Again, half is a common factor, therefore I can remove that thing. Then I can take M1 part to this side and M2 part to this side. Then it is very clear M1 into U1 squared minus V1 squared is equal M2 V2 square minus U2 square. If you got this calculation, if you got this simplification, please raise the hand. I need responses from everyone. If you cannot understand, please let me know. Okay. Then you can clearly understand, Pute, now there is a difference of squares. Therefore, you can write them as a difference of square. That means u1 minus v1 is square v1 into u1 plus v1 equal m2 v2 minus u2 plus v2 plus u2. This is second. Now what will happen if you divide second part by first term? If you divide second part by first term, then what will happen? Now it is very clear. M1, U1, V1 is here. Here M1, U1 minus V1 is here. M1 to M1 will be cancelled out. U1 minus V1, U1 minus V1 will be cancelled out. Is that clear? Therefore, remaining is U1 plus V1. Then here M2 will be cancelled out. V2 minus U2, V2 minus U2 will be cancelled out. Therefore, remaining is V2 plus U2. Therefore, if you divide 2 by 1, please listen to me very carefully because no need to write the entire equation. If you want to write, you can write. But remember this, you can cancel out them. Now I am going to divide 2 by 1. Please listen to me very carefully. 2 by 1. Therefore, if you divide 2 by 1 here, M1 to M1 will be cancelled out. U minus 1 will be cancelled out. Therefore, in left hand side, the remaining part is U1 plus V1. U1 plus V1 is equal. Right hand side, M2 will be cancelled out. V2 minus U2 will be cancelled out. Therefore, remaining part is V2 plus U2. V2 plus U2. Did you get my calculation? I did not write this division, but I have calculated that part. If you got my calculation, please raise the hand. Tevana Tusan. Tevana Tusan. Linet, Shashkuda. Vadate. Thank you. Hi. Now I can take initial velocities into one side, final velocities into other side. Initial velocities into one side, that means u1 minus u2 is equal v2 minus v1. This is very, very important equation. This is very, very important equation. So if there is a one-dimensional elastic collision with u1 minus u2 means actually that is the relative velocity before collision. No, relative velocity before collision. Relative velocity difference. The velocity difference means that is the relative velocity before collision. Relative velocity before collision is equal relative velocity after collision. But when you are taking relative velocity, initially you have, if you take u1 minus u2, then you have to take v2 minus v1. So this is the relative velocity before collision. This is the relative velocity after collision. Is that clear? If it is clear, please raise the hand. I had really the. Thank you. Therefore, this is the relative velocity before collision, here relative velocity after collision. After collision. And therefore, normally put before collision before collision objects are approaching they are approaching to each other. Therefore, we call this one as relative velocity of approaching. Relative velocity of approaching. Objects are approaching to each other. Then after collision, they will separate. They will separate. Therefore, we call this one as relative velocity of separation. Relative velocity of approaching, relative velocity of separation. No need to that time, no need to remember that part. But that is the word. Approaching and separation. Much so that we kata කරන්න එහෙම. Approaching. මට ඉංග්‍රීසි සමග මෙහෙම separation. ඕගොල්ලෝ ලියාගන්න හරියට. Therefore, if there is a elastic collision, elastic one-dimensional collision, relative velocity before collision is equal to the relative velocity after collision. But when you are taking relative velocity, if you take u minus 1 initially, u1 minus u2 initially, the final relative velocity should be v2 minus v1. අනිත් පැත්තට අවුල් කරන්න. මෙයාගේ මෙයා අඩු කරා නම් මෙතනදී මෙයාගේ මෙයා තමයි අඩු කරන්නේ. එච්චරයි උඩට ගන්න. හරි. If you got that one, please raise the hand. This is very, very important relationship. Okay. But remember, you cannot use this relationship in essay questions. This is for MCQs only. This is for MCQs only. And so if you want to use this equation in essay question, you have to deduct. But derivation is very easy. You can write these two equations and may just get the answer using your memory. No need to calculate nothing. මේක දැම්ම උන මේකට මේකට දැම්ම මේකට දෙකට දැම්ම 1 over 2 කියලා දාලා අරගත්තා නේ ඉවරයි. හරි. ඒ නිසා ඒක බය වෙන්න එපා. ඉතින් essay question එකක් ආවත් ඒ විදිහට හදන්න පුළුවන්. ඒකම දේ වාරේ මේ දෙක ලියන්න ඕනේ. මේ දෙක ලියලා ඊට පස්සේ තමයි ලියන්න පුළුවන්. Okay. Write down up to this. Okay, have a look at. Have finished. Okay. Okay, now there's a very, very special case in this equation. හොඳේ බලන්න. මේකේ තියෙන ලස්සනම කතන්දරේ. දැන් තමයි. මම ඒකට අදාළ වීඩියෝ එකක් ඕගලන්ට එවුවා. Okay. දැන් මම මේ කතා කරන හද දෙයට අදාළ මම වීඩියෝ එකක් දැන් මම ගෲප් එකට දැම්මා. That is about Newton's straddle පුතේ. Newton's straddle means that is a demonstration of one-dimensional elastic collision පුතේ. One-dimensional elastic collision බලන්න. And දැන් බලන්න එපා හිත පොඩ්ඩක් මේක කියන්නේ. ඔක්කොම දේ එක බලන්නේ. Okay. Now you know this one. Write on this, write on this, write on this. This equation is valid only for one-dimensional elastic collisions. This equation is valid only for one-dimensional elastic collisions. Write it another manner. This equation cannot be used for essay questions. This equation cannot be used directly for essay questions. This equation cannot be used directly for essay questions. Okay. Sorry. This is our first equation. This is related to linear momentum conservation. This is the first equation. So this is the equation we got from here. So I can write this one as 1 dash and 2 dash. So my objective is finding V1 and V2, final velocities. So if you want to find V2, it is easy. If you want to find V2, I have to remove V1. To remove V1, I have to multiply the second equation by M1. No? If you multiply the second equation by M1 and add these two, this one will be cancelled out. Okay? Therefore, if you multiply the second equation by M1, if you multiply the second equation by M1 and add with first equation, then what will happen? M1 V1 will be cancelled out. M2 V2 and M1 V2. M2 V2 plus M1 V2 is equal. මෙතන පුතේ M1 U1 එනවා. මෙතන M1 U1 එනවා. මෙතන M1 U1 එනවා. Therefore 2 M1 U1. මෙතන M2 U2 එනවා. M2 U2. මෙතන M1 U2. හරිද මම? ඔහොම. මෙතන M2 U2 minus M1 U2 කියන්නේ M1 U2 කියන්නේ. හරි. හරිද කාවල? හරිද බලන්න. M1 මෙතන M1 U1 M1 U1 2 M1 U1 මෙතන M2 U2 එහෙමමයි minus M1 U2 එහෙනම් V2 කියන එක මට සබ්ජෙක්ට් කරලා හැකි. therefore V2 is equal to M1 over M1 plus M2 into U1 plus M2 minus M1 over M1 plus M2 into U2. So this is the velocity 2. This is the velocity 2. Did you get my calculation? My calculation that kind of method U2 අයින් කරලා නැත්නම් M2 minus M1 එන්න පුතේ. Therefore you have to divide M1 plus M2 මෙතන subject කරලා පස්සේ all the equation by M1 plus M2. If you got this one, please raise the hand. මේක තේරුණා නේද උසන්? මෙතනින් වා මේකේ සබ්ජෙක්ට් කරොත් පුතේ මේ සෝරි මෙයා එළියට ගත්තොත් එහෙම M1 plus M2 P2 එන්නේ. හරිද? මේක සමානයි මෙන්න මේ ටික. මේ නිසා මේකෙන් බෙදුයි. මෙන්න එනවා අපිට V2. මෙන්න V2. This is V2. මේ කටපාඩම් කරගන්න එපා. කටපාඩම් කරගන්න එපා. මේ පොඩි ඉක්වේෂන් එකක් ගන්න විතරයි මම මේක ඕනේ. දැන් බලමු ඔගේ අනිත් පැත්ත පුතේ අපි දැන් මේක මට V1 ගන්න ඕනේ කියලා තමයි. V1 ගන්න ඕනි වුණොත් මට 1 dash subtract කරන්න ඕනි M2 into 2 dash 2. බලන්න. එතකොට මේ M2 V2 මෙතන M2 V2. Therefore if you subtract M2 V2 minus M2 V2 will be then V2 will be cancelled out. Therefore look at this one. M1 V1 minus M2 V1. M2 V1 minus M2 V1. Therefore it will be plus then. It will be plus M2 V1 is equal M1 U1 M1 U1 M1 U1 මෙතන M2 M2 U1 M1 U1 මෙතන M2 U1 it will be minus. Therefore M1 U1 minus M2 U1. Then M2 U2 එහෙම වෙනවා M2 U2 M2 U2 මෙතන M2 U2 minus M2 U2 means plus M2 U2 plus M2 U2 plus M2 U2 that means 2 M2 U2 2 M2 U2. Therefore V1 බලන්න ඒ වගේම එකක් තමයි එන්නේ V1 is equal to M2 U2 2 M2 over M1 plus M2 මෙයාව සබ්ජෙක්ට් කරපුවොත් M1 plus M2 මෙතන M1 plus M2 මෙතන එන්නේ U2 පුතේ U1 වෙනකොට U2 එන්නේ M1 වෙනකොට M2 එන්නේ plus M1 minus M2 M1 plus M2 මෙතන U1 එන්නේ මේකෙම අනිත් පැත්තේ මේකෙම අනිත් පැත්තේ M2 වෙනකොට M1 වෙනකොට M2 තියෙනවා U2 වෙනකොට U1 තියෙනවා මෙතන U1 වෙනකොට U2 තියෙනවා මෙතන M1 minus M2 එන්නේ M1 minus M1 උදේ මෙන්න V1 වෙනවා හරිද Did you get my calculation? If you got my calculation, please raise the hand. තේරෙනවද උත්සන්? මේවා කටපාඩම් කරගන්න ඕනේ නැහැ. කිසිම දෙයක් කටපාඩම් කරගන්න ඕනේ නැහැ. මට මේ ඊළඟ මේ රිලේෂන්ෂිප් එක විතරයි මේක ඕනේ. හරි. 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 මේක දාගන්න පුතේ. මේක ලියන්න පාවන්න මේක ලියන්න. Okay, have finished. Have finished. Clear the මම මේ යන්නේ පුතේ MCQ වලට රක් ගාලා උඩ තියාගන්න ඕනේ. මතක තියාගන්න ඕනේ කාරණාවක් කියලා දෙන්න. හරි. නැත්තම් මේක අර පොසිෂන්ස් වලට යද්දි මේ මෙච්චර කැල්කියුලේෂන් ඕනේ නැහැ. පොසිෂන් වලට යද්දි ඔයාලා දාගෙන තියෙන ලීනියර් මොමන්ටම් කන්සර්වේෂන් එකයි එනර්ජි කන්සර්වේෂන් එකයි if it is a elastic collision you have to apply linear momentum conservation and energy conservation only. So you can calculate. And but now I'm going to teach you some special short methods to remember when you are doing MCQ questions. මේක MCQ questions කරනකොට ආයි හදා ඉන්න වෙලාවක් නැහැනේ. ටක් ගාලා බලුවා මොකද්ද තියෙන්නේ කියලා බලුවා ආන්සර් එක උඩින් මතක් කරගත්තා. හරිද? ඒක නිසා මේ MCQ කරන්න short method එක. හරිද? ඒකයි. ඒ නිසා මේ calculation එක no need to. No need, but you have to remember the final, you have to remember the final output, okay? But I have to teach you, no? Therefore, I have to simplify this one. Right? Okay. Have finished? Have finished. Okay. Now, there are several special cases. There are actually mainly three, but maybe we can consider it as four. There are four special cases. You have to clearly understand those. First one. Right on that. There are several special cases in one-dimensional elastic collisions. There are several special cases in one-dimensional elastic collision. දැන් මේ එන්නේ කොහොමද කියන දේ තමයි මම මේ කියන්නේ. හරිද? එන්නේ කොහොමද කියන දේ කියා දුන්නාට පස්සේ you have to remember the final output. හොඳට. You have to remember the final output. Therefore, when you are doing MCQ questions, no need to worry about how we derive this one, how to derive this one. No need to worry about that one. You have derived about it. Therefore, then you can apply that one into MCQ. Right? Please listen to me very carefully. If you have any doubt thing, please let me know. Right? Therefore, first topic. When M1 equivalent to balance. When M1 equivalent to means if two masses are equal, what will happen to them? What will happen? If M1 equivalent to this part will be 0, this part will be 0, this part will be 0, this part will be 0. Therefore, if M1 equivalent to what will happen? V2 is equal to M1 plus M2 over U. And now M1 equal M2. Therefore, V2 is equal to M over M plus M. M plus M means again 2M. Again 2M into U1. U1. This part is 0. That means V2 is equal U1 putih. V2 is equal U1. Look at this one. Here. As M1 equal M2, this part will be 0. This part will be 0. Therefore, V1 is equal, V1 is equal 2 and 2. Let us 0 to that. 2m over 2m over again m plus m is m 2m into u2 plus 0. Again 2m to 2m will be cancelled out. Then v1 equal u2 putih. What happened here? What happened here? මොකද වෙලා තියෙන්නේ? බලන්න. This is very, very important relationship with it. And look at this one. Initial velocity is now m into u1. Here, m into u2. Then, suppose this one is A, this one is B. Now, velocity of A is equal V1. Now, V1 is equal U2. V1 is equal U2. V1 is equal U2. And velocity of B is equal V2. V2 is equal U1. What happened here? Huh? After the collision, A will have the velocity of B. B will have the velocity of A. That means if there is elastic collisions of equal masses, their velocities will be exchanged. Therefore, you do not want to calculate anything if there is a elastic collision with equal masses. Just change the velocities. Just exchange velocities. Therefore, if there is a mass come with 4ms minus 1 and hit with another mass is 2ms minus 1, this mass will be moved with 2ms minus 1 and other mass will be moved with 4ms minus 1. Therefore, initial velocities will be exchanged. Did you get my point? තේරුණා? පැහැදිලිද? තේරුණා තුස්සන්න? Okay, now you can write this one right up to this. මේක තමයි මේ පාඩමේ තියෙන වැදගත්ම කතන්දරේ. කතන්දර දෙකෙන් එකක් හොඳේ. එකක් මේක ඊළඟට ඊට පස්සේ එන ලෙසන් එක මොකද්ද මේ center of mass. Center of mass නම් ටිකක් අමාරුයි. ඒ නිසා අපි ඊළඟ සෙෂන් එක නම් මේ හොඳට මේ කාලා බීලා හොඳට වෙලා හොඳ නිදිමත නැතුව හොඳට අහන් ඉන්න වෙනවා. Center of mass එක කියන්නේ ටිකක් අමාරු questions හොඳේ. Alright, so if there are two masses, one is moving with 5 ms minus 1 and other one is moving 2 ms minus 1. After collision of this one, if it is an elastic collision, then suppose this mass are equal. If mass are equal, if mass are equal, if mass are equal, mass equal in if mass are equal, definitely velocity will be exchanged. Velocities will be exchanged. And this is the most important scenario. This is the most important scenario of this relationship with it. But suppose now simple m mass moves at the speed of u, and here there is a mass at rest. Here A, B. Here mass at rest for you. The mass now is at rest. Then after collision, what will happen? 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 A will come to rest condition. A will come to the rest condition. A will come to the rest condition. Its velocity will be 0. Then B will move at a speed of A, initial speed of A. We will move at the initial speed of A. මෙයා ඇවිල්ලා වැදිච්ච ගමන් මෙයා මේ රෙස් කන්ඩිෂන් එකට ඇවිල්ලා අනිත් එක්ක යනවා. ඔන්න ඕක තමයි මම එක වීඩියෝ එකේ තියෙන්නේ නිව්රස් පැරල්. නිව්රස් පැරල් එකේ අපි මේ පෙන්ඩුලම් එක මෙහෙම ඇදලා අතහැරපු ගමන් අර පෙන්ඩුලම්ස් ටික පුතේ මෙහෙම තියෙන්නේ. ඔන්න ඕක තියෙන්නේ. මම මෙයාව මෙතන පෙන්ඩුලම් එක ඇදලා අතහැරපු ගමන් මොකද වෙන්නේ? මේ ඇවිල්ලා මෙතනට වදිනවා. වැදිච්ච ගමන් මූ ප්‍රෙස් වෙනවා. මෙයා එනවා මෙයා වදිනවා. මෙයා රෙස්ට් වෙනවා. මෙයා මේකේ මෙයා වදිනවා. ඊට පස්සේ මෙයා මූ රෙස්ට් වෙනවා. හරිද? අන්තිමට ඔයාලට පේන්නේ මෙයා වැදිච්ච ගමන් මේ ඔක්කොම රෙස් කන්ඩිෂන් එකේ ඉන්නවා. මෙයා මේ පැත්තට වදිනවා. හරි? හරි මොකද? මෙයා ඇවිල්ලා වැදිච්ච ගමන් මේ ස්පීඩ් එක මෙයා ගන්නවා. ගත්තට වැලක් නැහැ. ගත්ත ගමන් අනිත් පැත්ත වදිනවනේ. ගත්ත ගමන් අනිත් පැත්ත වදිනවා. එතකොට මෙයා ගත්ත ගමන් ආයෙසරක් රෙස්ට් වෙනවා. ඊට පස්සේ මෙයාගේ ස්පීඩ් එක කියලා ස්පීඩ් එක වෙන මෙයාගේ මේකේ වදින හැබැයි වැදිච්ච ගමන් මෙයා රෙස්ට් වෙනවා. ඊට පස්සේ මෙයාගේ වදිනවා වැදිච්ච ගමන් එයා රෙස්ට් වෙනවා. ඒ නිසා මේ අතරමැද තුන් දෙනාට ස්පීඩ් එක හම්බ වෙන එකයි රෙස්ට් වෙන එකයි පුතේ ටක් ගාලා අපිට පේන්නේ නැහැ. හරි? මේක ලෝකෙට ගෑවිලා නේ. හරි? ඒ නිසා මේක අතරම මම අපිට පේන්නේ මෙයා විල වැදිච්ච ගමන් මේ කෙරවල තියෙන කෙනා විතරක් එළියට හම්බෙන්නේ. මෙයා විල වැදිච්ච ගමන් මේ ඔක්කොම හෙල්ලෙන්නවත් නැහැ ඉතුරු එක්කෙනෙක්වත් කෙරවල ඉන්න කෙනා විතරක් මේ මොකද වෙන්නේ? මූ වෙනවා අපේ. දැන් බලන්න වීඩියෝ එක. හරි. එහෙනම් මෙතනදී මේ එකක්වත් හෙල්ලෙන්නේ නැහැ. අන්තිම එක්කෙනා විතරක් මූ වෙනවා. ඒක තේරුණාද? So this is the theory behind Newton's cradle. Newton's cradle එකේ theory එක තමයි මේ තියෙන්නේ. So once you write this one, please කොටු කරා යන්න. This is very, 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 very important relationship. Because there is there were several questions regarding this one. Actually, in 2019, Puti, there are at least 5 or 6 collisions may, as I remember, 4 again. There were, yes, at least 4 or 5 balls. 4 or 5 balls. That means at least there are that much of collisions. If you do not know this relationship, you have to apply linear momentum conservation and energy conservation for each collisions to solve that question. Therefore, if you follow the basic rules, then definitely you cannot do another questions rather than that question. And therefore, definitely you have to have that knowledge to answer MCQ question. එනයි අදහදින්න එපා මෑත්ස් එක ඉක්වල් නම් කොලිඩ් වෙනවා නම් මෑත්ස් එක ඉක්වල් නම් කොලිඩ් වෙනවා නම් අනිවාර්යෙන් මේක ස්ටෙන්ඩ්. Okay. They write on this. They write on this. That means if the masses are equal, velocities will be exchanged during the collision. Velocities will be exchanged during the collision. Velocities will be exchanged during the collision. Okay. There is a second relationship. The second relationship means when U2 is 0. U2 is 0. U2 0 U2 0 U2 0 means that means this kind of scenario. M1 U1. Now M2 is that test condition with it. And so after collision, what will happen? Now it is very clear if the masses are equal, velocity will be exchanged. Now masses are not equal. Okay? Now this is a common scenario. V1, V2. Therefore, now it is very clear from the equation. Okay? This part will be 0. This part will be 0 because U2 is 0. Therefore, V1 is equal. Therefore, V1 is equal M1 minus M2 over M1 plus M2 into U1. එහෙනම් මෙයා පළවෙනියා ඒ කියන්නේ මේ ඇවිල්ලා හැප්පිච් එක කෙනා ඉන්නවනේ. එයාගේ ස්පීඩ් එක. ඇවිල්ලා හැප්පිච් එක කෙනාගේ ස්පීඩ් එක is equal difference of masses over addition of. Actually, in the denominator, there's addition of mass. Therefore, no need to worry about that thing. Numerator, difference of masses. Difference of masses today. M1 minus M2. M1 minus M1 minus M2. Okay? M1 minus M2. M1 minus M2. This is P1. මේක නම් ලොකුවට මතක තියාගන්න ඉක්ුත් නෑ ටක් ගාලා හදලා ගන්නත් පුළුවන්. හරි. මොකද අපි දන්නවනේ ඉක්වේෂන් එක නිසා මේක ලොකුවටම දාගන්න ඕනේ නෑ. මේක ලොකුවට මතක තියාගන්න ගන්න ඕනේ හදලා ගන්න පුළුවන් අපි ඉක්වේෂන් එක දාන නිසා. ඊළඟට V2. So V2 is equal to this part will be 0. This part will be 0. Therefore, that is equal to M1. 2M1. Over U1 ගෙන් තමයි ඔක්කොම එන්නේ. 2M1 U1 over M1 plus M. අවුලක් නැති මතක තියාගන්න පුළුවන්. U1 විතරට තියෙන්නේ. එකක් M1 අනෙක් 2M1 අනික M1 minus M2 මේ දෙක විතරයි මතක තියාගන්න ඕනේ. දෙක ඔක්කොම. කොහොමද එකයි? This is the second. Third one. If M2 is very, very large than M1 and M2, sorry, U2 is 0. U2 means 0 means M2 is at rest. M2 is at rest. That means this kind of scenario. M1 is very little mass, but M1 is very little mass. Very little mass moving at the speed of U1. Now, M2 is a very huge mass, something like very huge stone or mountain or something. Okay? Very huge mass. Very huge mass, which is at rest condition. Then what will happen? මේක නිකම් පුතේ හරියට බිත්තියට බෝලයක් ගහනවා වගේ. බෝලයත් එක බලනකොට බිත්තිය මොන වගේද? ඈ? That is a very huge mass පුතේ. So if you compare the wall with the ball, then what can you say? The wall means that is a very huge mass compared to ball. So if you throw a ball onto a wall, what will happen? What will happen? Definitely, the ball will bounce back. The ball will bounce back, but the ball will never move. That means this huge mass will never move. That means V2 will be 0. V2 will be 0. This will never move, but this will bounce back at the same speed. This will bounce back at the same speed. Now we can prove. So how to prove? Now M2 is very huge. M2 is very huge. Make a good argument. This one is very high. This one is very high compared to V1. Sorry, compared to M1. Compared to M1, M2 is very huge. And U2 is 0. U2 is 0. As U2 is 0, this part is 0. This part is 0. This part is 0. And you know, M2 is very, very huge number than M1. And හරියට මේක මේ වගේ. M1 is 1 kilo. M2 means 1 lakh. 1 kilo and 1 lakh. Therefore, if you calculate 1 minus 1 lakh means 99,999. No, Then 1 plus 1 lakh means both are same. Both are same. Therefore, if you consider this M2 is very, very huge number relative to M1, then M1 minus M2 and M1 plus M2 both are equal. We can consider them are equal. Did you get my point? You can take that example. Suppose M2 is 1 lakh, M1 is 1 kilo. Therefore, 1 minus 1 lakh means 99,999. And then 1 plus 1 lakh means both are almost 1 lakh. Therefore, here, what will happen? V1 is equal, initial part is 0, 0 plus M1 minus M2 over M1 plus M2 into U1. You know, as M2 is very huge number, we can neglect the effect of M1. Therefore, as M2 is very, very huge number than M1, this one can be written as, V1 can be written as minus M1, so minus M2 or plus M2. Okay. I can remove M1 because effect of F1 can be neglected. Okay? Therefore, M1 to M1 will be cancelled out. Therefore, V1 is equal minus U1. Okay. Therefore, V1 is equal minus U1. That means this will bounce back. Therefore, this will bounce back. Here into M1 will be bounced back at the same speed. Okay. Therefore, no need to calculate the other part because now this is the initial momentum. The magnitude of initial momentum is equal to the magnitude of final momentum. Therefore, this part definitely should be remains as 0. This part should be remains as 0. Therefore, V2 should be remains as 0. Did you get my point? පැහැදිලි නැතු උස්සන්න. මේක හොඳම example එක බෝලයක් බිත්තර ගහනවා කියලා විතරයි. බෝලයක් බිත්තර ගහනවා කියලා. That is a very, very convenient example. Did you get my point? If you get my point, please raise the hand. තේරුණාද උස්සන්න? Thank you. Therefore, if you are given two masses and one mass is very huge relative to the other mass, then after the collision you can take the biggest mass is at rest condition, then you can say after the collision the first mass will be bounced back without affecting to the second mass. Okay, then I have this. Then I have this. Therefore, if a very small mass, if a is very small mass, if a very small mass collides with a very huge mass, collides with a very huge mass, which is at rest, comma, then the small mass will be bounced back at the same speed. The small mass will be bounced back at the same speed. The large mass remains stationary. The large mass remains stationary. Okay, you can write an example. For the example, collision of a ball with a wall. Collision of a ball with a wall. Then the fourth case. Fourth case is when M1 is very huge. When M1 is larger than M2 and U2 is 0. Maka dia ini nih, මේ අලියෙක් ගිහිල්ලා කුඹියෙක්ගේ ගැහුණා වගේ ලක්නේ. බලන්න. පුතේ අලිය ඉන්නවා. This is M1 පුතේ. It has a very huge mass. Now it moves at a speed of U1. Now M2 here, there is very small mass. M2, and it is at rest condition. Now, what will happen? What will happen? මොකක් වෙයිද? චප්ප ජුලුස් වෙලා එන්න. හරි බලන්න පුතේ. Now U2 is 0 පුතේ. Now U2 is 0, therefore this part is 0. This part is 0. No need to worry about that thing. Therefore V1 is equal 0 plus M1 minus M2 U1 over M1 plus M2. Okay. Now M2 is very small, but M2 is very small, therefore we can neglect M2. as M2 is very small, as M2 is very small, M2 can be neglected. Therefore, V1 is equal to the M2 M1 over M1 U1 to the. Therefore, V1 is equal to U1. That means the speed of this large mass will not change. The speed of this large mass will not change. V1 and is equal to U1. It will not change. Again, dead never double. Balo. Now V2. V2. Now V2, this part will be 0. No? This part will be 0. Because U2 is 0. U2 is 0. As U2 is 0. Again, as U2 is 0, V2 is equal to M1 over M1 plus M2 U1 plus 0. Again, M2 can be neglected because it is very small. Again, M2 can be neglected. Therefore, M2 can be neglected. Therefore, V2 is equal to M1 over M1 U1 to the. Therefore, M1 to M1 will be cancelled out. Therefore, now U2, V2, so V2 is equal 2 times V1 to the. That is very important thing. That means this is small mass will have 2 times of the velocity of the initial mass. And within a 2U1. V2 is equal to U1. V2 is equal to U1. I had the pair on the system. I had the at the someone. Right. Write down this thing. Very good. അതേപോലെ. Okay, so those are the very special cases in uh, one-dimensional elastic collisions. So you have to remember those special cases. It will be helpful when you are when doing MCQ questions with it. Okay. Now write the topic. Two-dimensional elastic collisions. Two-dimensional elastic collisions. Two-dimensional elastic collisions. Within brackets, oblique collisions. Oblique collisions. Two-dimensional elastic collisions. Or oblique collisions. Right. මේක නිකන් අර කරන් ගහනවා කියලා තමයි අපි කරන් ගෙවුවට පස්සේ මොකද වෙන්නේ අපි සාමාන්‍යයෙන් අපි කරන් අර මේ ඩිස්ප්ලේ එකකට පස්සේ අනිවාර්යෙන් ඒක ඉත්ත ඇවිදලා පස්සේ අනිවාර්යෙන් දෙපැත්තට යන්න පුළුවන් නේ. ඒ කියන්නේ ලීනියර් කොලිෂන් එකක් නෙවෙයි. ලීනියර් කොලිෂන් එකක් නෙවෙයි. ප්ලේන් එකේ 2D ම යන්න පුළුවන්. හරියට බිලියඩ් බෝල් ඒව ගත්තොත් එහෙම ඒක plane එක තියෙන. ඒ කියන්නේ 2D plane එක තියෙන. Therefore, such kind of collisions are called 2D collisions, two-dimensional collisions. That means after the collision, the direction can be changed with it. Directions can be changed. That means so after the collisions, direction is not the same straight line. Anyway, something like this. Anyway. Or suppose now this is the M1 moving at Q1 speed. Now here M2 at rest condition. So after the collision, this calculation after the collision, M2 goes in this direction and M1 goes in this direction. So those kind of collisions are called oblique collisions or otherwise two-dimensional collisions. So in such cases, actually as we discussed in earlier, in such cases, we need to determine linear momentum conservation in two perpendicular direction. It may be horizontal and vertical or any convenient two perpendicular directions. Therefore, you have to determine the linear momentum conservation in two perpendicular direction. That is the only thing. Others are okay. Here you have to determine the linear momentum conservation in two perpendicular directions. Therefore, I can consider the linear momentum conservation in two perpendicular directions. Linear momentum conservation for the system in y direction. In y direction. And then in y direction, initially put there's no momentum in y direction. There's no momentum in y direction because the momentum is in x direction. Initial momentum was in x direction. There is no momentum in y direction. Finally, suppose this one is theta, this one is alpha. Finally, the momentum in upward direction is m2 v2 cos theta. m2 v2 cos theta minus, this one is in downward direction, m1 v1 cos alpha. m1 v1 cos alpha. This is one equation. The secondly, I can apply linear momentum conservation into x direction. The initial momentum is m1 u1. The final momentum of the system is m2 u2 sin theta. m2 v2 sin theta, that is into the same direction, and m1 v1 sin alpha, that is into the same direction. m1 v1 sin alpha. This is second equation. Third equation I'm going to put as this is an elastic collision. As this is an elastic collision, then I can apply kinetic energy conservation. Therefore, as this is elastic collision, kinetic energy is conserved. The initial kinetic energy is half m1 u1 square is equal. Kinetic energy doesn't have direction. Final kinetic energy is half m2 v2 squared plus half m1 v1 squared. So those are the three relationships that can be used when there is a two-dimensional collision. Two-dimensional collision. Did you get my application, my calculation? Did you get my explanation? If you got that one, please raise the hand. I need response from everyone. If you want to explain it again, please let me know. Okay. They write this one, okay. If there's a two-dimensional collision, the principle of linear momentum conservation. The principle of linear momentum conservation can be applied can be applied in two perpendicular directions. Can be applied in two perpendicular directions. Write it on the para. As this is an elastic collision, as this is an elastic collision, as this is an elastic collision, the principle of energy conservation can be applied to okay. Now you can draw this one. Make an amount there. Make one. No need this one. No need this one. Just write this. Okay, I finished. අර ඉන්ටර්වල් එකක් එපා කියන සදිකටම ගෙනියන්නේ ඕනේ ඉන්ටර්වල් එක. මේ ඔයාට ඔය ආල ප්‍රශ්නෙම තිබ්බ පුතේ මේ මම හිතන්නේ අපි ඕලල් කරන කාලේද බරෝ මුදල් ඕලල් කරන කාලේ මම හිතන්නේ බල ඉවදලත් නැහැ ඒ කාලේ මේ මොකක්ද এডুকেෂන් මිනිස්ට්‍රි එකේ මේ සෙක්‍රටරි කෙනෙක් අධ්‍යාපන ලේකම්ට හරිද අධ්‍යාපන ලේකම් හිටියේ තාරාදිපුලි කියලා ඒත් ඔය චඩ්විකයි කාලේ මේ මිනිහේ ඒ ගෑනු කෙනා ප්‍රොපෝස් කරා බයෝ කරන කට්ටියට ෆිසික්ස් නැතුව මේ පොලිටිකල් සයන්ස් මේ ඔය ඉතින් මොලේ තමයි ඉතින් මොකද බයෝ කරන කට්ටියට ෆිසික්ස් ඕනේ නැහැ කියලා. හරි ඒ කාලේ මාර මේ කියන්නේ මට කතිකාවතක් ගියේ කෙනෙක් මාරව කම්පියුටර්ස් ගොඩක් ආව මේ ඩිසිෂන් එකක් එක ඒවල ලත්තර ලොක්ුණා මේ බයෝ ගන්න කට්ටියට විශේෂ නැතුව උත් කරන්න බෑ. ඉතින් දැන් හිතන්නකො මැෂින්ස් ගත්තොත් එහෙම මෙඩිකල් ඉන්ස්ට්‍රුමන්ට්ස් ඔක්කොම තියෙන්නේ මේ ඒ ඔක්කොම ෆිසික්ස් වලින් තියෙන්නේ. ඊළඟට අර මේ මොකක්ද ඔය අපි කියන්නේ මේ ඔය අතපය කරනට පස්සේ ඉතින් තියෙන අර ඔපරේෂන්ස් තියෙන තනිකරම මේ මම ඕලෙවල් කිව්වා මම දන්නේ මේ ළඟදී මගේ යාළුවෙක් එක්සෙනට් වෙලා ඒත් එහෙම අර තනිකර ප්ලේට් එකක් දාලා තිබ්බා. මේ ඒක තනි කරම මැකනික්ස් පාර්ට් එක. ඒ කියන්නේ මැකනික්ස් කියලා කියන්නේ කෙලින්ම මේ ડોක්ටර්ස්ලා කෙලින්ම මැකනික්ස්ලා වගේම තමයි වැඩ කරන්නේ. මේ මොකද තනි කරම මේ ඔපරේෂන්ස් කියන්නේ තනි කරම මේ කොහොමද මේ ජංක්ෂන් එකක් වැඩ කරන්නේ කොහොමද මේ ජංක්ෂන් එක ලෝඩ් දෙන්නේ ඒව හැම මොකක්ම ඕනේ. හරි මේ වැඩි නෙවෙයි ඉතින් අල්ට්‍රාසවුන්ඩ් ස්කෑන් ගත්තොත් එහෙම ඒවා තියෙන ෆිසික්ස් පාර්ට් එක. ලේසි නෑ. මේ ෆිසික්ස් පාර්ට් දන්නේ නැතුව කොහොමද අල්ට්‍රාසවුන්ඩ් ගැන කතා කරන්නේ? කොහොමද ඒකෙන් අපි කියවගන්නේ? තනි කරම ෆිසික්ස් ලෝකයක් තියෙන්නේ. මෙඩිසින් කරාට ෆිසික්ස් ලෝකයක් තියෙනවා. ඔය කියන්නේ ෆිසික්ස් දන්නේ නැතුව ඉතින් එතනින් එහාට යන්න බෑ මෙඩිසින් කට්ටියට. මේ එකම දේ අර මේගොල්ලන්ට අර මේ මැත්ස් පාර්ට් එකේ අවශ්‍ය දේවල් සමහර තැන් කරොත් හොඳ කියලා මට තේරෙනවා. අර සිලබස් එක තියෙන ලොකු විසම අර ඩිෆරන්ෂියේෂන් ඉන්ටග්‍රේෂන්ස් පාර්ට්ස් එක පොඩ්ඩක් ඒවා තියෙනවා නම් පොඩ්ඩක් තේරුම් ගන්න ලේසි. මේ දැන් අපි ඒව කරන්නේ නැහැ. ඒවට දැන් සාමාන්‍ය ඉන්දියන් එක්සෑම් එකක් අනම් මනම් ගත්තොත් ඉන්දියන් නෙවෙයි තියෙන්නේ. හැමතැනක ගත්තොත් එහෙම මේ සාමාන්‍ය මෙඩිකල් ඉන්ස්ට්‍රුමන්ට්ස්ලාට ඒවා තියෙනවා. මේ දැන් අපි ඔය අපේ දැන් මම ඒක පොත ගන්න ඔය ඔබ්ජෙක්ටිව් ෆිසික්ස් බුක් එක ඊට පස්සේ ඒ වගේ ඔය තියෙන මේ පොත් බලන්නකො. දැන් ඒවැ සාමාන්‍ය මේ පාර්ට් එකත් මෙඩිකල් ඉන්ස්ට්‍රුමන්ට්ස් වලට කතා කරලා තියෙනවා. ඒ කියන්නේ මොකක්ද? එතකොට ඒ කියන්නේ ඒක තේරුම් ගන්න ලිසන්ස්. දැන් මේ අපි ෆිසික්ස් කියලා ලංකාවේ කතා කරන දේ ඇතුලේ අර මැත්ස් පාර්ට් එක පොඩ්ඩක් බරතැන් තියෙනවා. ඒ තැන් නිසා තමයි ඔය පොඩි මතයක් ගිහින් තියෙන්නේ. අර බයෝ කරන කට්ටියට ෆිසික්ස් තමයි කියලා. ඒ වුණාට මැත්ස් පාර්ට් එකේ තියෙන මැකනික්ස් වල විතර. මැකනික්ස් වල විතරයි තියෙන්නේ. ඉතින් එහාට ඔක්කොම තියෙන්නේ මැත්ස් පාර්ට් එකේ. හරි. ඒ කියන්නේ අපිට මෙතනින් එහාට කියන්නේ සිම්පල් හාමොනික් මෝෂන් එනවා ඊට පස්සේ මේ තර්ඩ් ලෙසන් එකේදී සිම්පල් හාමොනික් මෝෂන් එකෙන් පස්සේ මැත්ස් කරන කට්ටිය බයෝ කරන කට්ටිය දෙකොල්ලම එක්ක. හරි. සිම්පල් හාමොනික් මෝෂන් එක වෙනකන් විතරයි මැත්ස් කරන කට්ටිය පොඩ්ඩක් අප් වෙලා ඉන්නේ ඒ අරනම වෙන කිසිම දෙයක්. එතනින් එහාට ඉතින් දෙකොල්ලා අනිවාර්යෙන් ඉක්කොල්. එතකොට එතනින් එහාට ඉතින් ආයි කතා කරන්න බෑ බයෝ කරන කට්ටියට. හරිද? ඒක මොකද අනික දැන් ඔය බයෝ කරන කට්ටියට මේක ලංකාවේ අමාරු වෙන්නේ. ලංකාවේ බයෝ කරන ස්ටුඩන්ට් කෙනෙක් ඇත්තටම මේ ගොඩක් වෙලාවට මේ අර තේරුම් ගන්නවට වඩා පාඩම් කරන්න යන්නේ. තේරුම් ගන්නට වඩා පාඩම් කරන්න යන්නේ. ඒකත් එක්ක අර ලංකාවේ එක්සෑම් සිස්ටම් එකේ තියෙන ප්‍රශ්න විතරයි තියෙන්නේ. ඒ වෙන්නේ මේ බයෝ කරන කට්ටියට ෆිසික්ස් අවශ්‍යයි. අනිවාර්යයෙන් අවශ්‍යයි. හරි. ඒ වැඩිනේ ඔයගොල්ලෝ කොහොමද ECG එකක් කියවන්නේ? ડોක්ටර් කෙනෙක් ECG එකක් කියවන්නේ කොහොමද? ඈ ට්‍රිගොනොමෙට්‍රි දන්නේ නැත්නම් ECT එකක් කියවන්නත් බෑ නේද? හරි. එතකොට තනි කරලා තියෙන මේ ඔය ට්‍රිගොනොමෙට්‍රික් කර්ව් එකක් තියෙනවා. ඒක නිසා ඒ කිසිම දෙයක් අර අපි සාමාන්‍යයෙන් කියන ෆිසික්ස් වලින් මැත්ස් වලින් තොර සයන්ස් එකක් නෑ. ෆිසික්ස් වලින් මැත්ස් වලින් තොර සයන්ස් එකක් නෑ. මොකද ෆිසික්ස් කියලා කියන්නේ නැචරල් ෆිනොමිනා එක්ස්ප්ලেইন කරපු සයන්ස් එකක් නේද? ඒක ඇතුලේ තමයි ඒක ඔක්කොම ටික තියෙන්නේ. බයොලොජි කියන්නේ වෙන පාර්ට් එකක්, බයොලොජි කියන වෙන පාර්ට් එක වුණාට බයොලොජි අපිට යූස් කරන පාර්ට් එකට නමුත් අවසානයේදී හැම වගුලම ඇති වෙලා තියෙන විදිහ කොහොමද ඒක ප්‍රොසෙස් වෙන්නේ කියලා ඔක්කොම ටික එක්ස්ප්ලেইন කරන එකම තමයි ෆිසික්ස්. ඒ නිසා අනිවාර්යයෙන්ම ඔය නෑ ඕකේ දවස්වල මා ලස්සන කතාවක් ආ පොලිටිකල් සයන්ස් දෙන්න හැදුවා ෆිසික්ස් වලින්. Okay. So you can take a break. Break එකක් අරගමු නේ. Break එකක් අරගමු 8:15. We can start 8:15 again. That our later part, that means the second session will be very crucial Pate, because we will discuss about center of mass. Center of mass. Center of mass especially related to linear momentum conservation. And that part has to be understood very well because there may be some hard questions related to that part of the center of mass. Center of mass related to linear momentum conservation. හරිද? එහෙනම් ඊළඟ පාර්ට් එකට පොඩ්ඩක් මේ සෙට් වෙලා යන්න නිදිමත ඉන්න නම් එපා. මට නිදිමත අවශ්‍ය දෙන්නේ. මොකද්ද? අනිවාර්යෙන් 8:15 වෙනකොට එන්න 8:15 වෙනකොට එන්න පොඩ්ඩක් අමාරු ලෙසන් එකක්. හරි. Okay. We can take a break, okay? Break එකක් කරගන්න. Hmm. Alright. Kata bila ni. Okay. If you're in the class, please may give me a thumb. Thank you. Yeah. Okay, but as I discussed with you earlier, you have to understand this part very well because there may be some difficult questions related to this part today. Therefore, please listen to this very carefully. If you have any doubt, please let me know. Okay. Uh, the right topic: set of mass. Set of mass. Okay. Uday, you know how to determine center of gravity, no? How to determine center of gravity. So if you consider a center of gravity, suppose this is x, sorry, this one y, this one is x, and let's say this is the object. Suppose now there are four masses at four corners. The method 2 kg, 3 kg, uh, then again 4 kg, 1 kg. Okay. Suppose there are four masses in a square in the vertices of square as in the figure. Now let's say this one is 2, this one is 1, this one is 4, 3, again. Now, how to determine my set of gravity? How to determine set of gravity? So in that case, we can consider the center of gravity will be somewhere here. Okay? Then the total, the center of gravity means resultant force of them. Resultant force of them. Then, so what is resultant force? 10 kg. 10 kg. Then, let's say the coordinate of this one is x bar, y bar. That means this height is y bar, this one is x bar. Okay. Now you can take the moment about x-axis and y-axis, no? Take the moment about x-axis and y-axis. Using the principle of moment, you can take x bar and y bar. Okay? Whether the monkey or product, මෙහෙම නැත්නම් පොඩ්ඩක් angle කරලා ඇද ගන්න. එතකොට lazy මේ perpendicular lens ගන්න කියලා. හරි? Okay. So if I want to take y bar, now so if you take the moment about y-axis, moment of a resultant force, moment of the resultant force means 100 Newton to y bar. 100 Newton to y bar. මේක වටේ ගත්තොත් මේ මම කිව්වා මේක perpendicular එකට මෙහෙම හිතන්න කියලා මම කිව්වා. එතකොට y bar into 100 Newton is equal addition of other moments by other forces. Okay. 1 kg into 4, 4. 1 kg means 10 Newton into 4 plus 40 Newton into 3. 40 Newton into 3. Then 30 Newton into 3. Method 20 Newton into 1. 20 Newton into 1. Sorry. 10 kg into 1 of the 4 days. Sorry. 10 kg into 1. 10 kg into 1. Okay. Whether 10 kg into method perpendicular distance is 1. Method perpendicular distance is 4. 3. Method 3. Method 1. 20 into 1. So that is the principle of moment about y-axis. Then you can determine y bar. Y bar is equal. මෙතන පුතේ 10යි මෙතන 120යි 120යි මෙතන 210යි 210යි 30යි 270 OC. That means 2.4 here. 2.4. Then you can take the moment about x-axis. If you take moment about x-axis, again 100. Result force is 100. Remember 100 with 100 into this length, this height. Sorry, with the method x bar. Sorry, x bar. Method x bar, may expect that in the. So if you take moment about x-axis, then y distances will be there. Mean 100 into y bar, 100 into y bar is equal 20 into this side 2, 30 into this side 2, 20 into height 2, plus 30 into height 2, plus 40 into this length is 4, okay, this length is 4. Plus 10 into this length is 4. 10 into this length is 4. කොතනද පුතේ? හරි නේද? දැන් හරිනේ? බලන්න කලුනේ. හරි. 1 එකත් එක්ක තියෙනවා 20 එකයි 10 එකයි 3 එකත් එක්ක තියෙනවා 40 එකයි 20 එකත් එක්ක තියෙනවා 2 එක 30 එක 40 එකයි. එතකොට පුතේ මෙතන එනවා 15 to 200 15 to 200 ඊළඟට 15 to 4 200 then 300. Therefore y bar is 3. Y bar is 3. So this is the where you take the center of gravity. Did you remember this one? Mega Matakadu? If you got my calculation, please raise the hand. This is based on principle of moment. I need responses from everyone because this is totally a discussion today. Therefore, I need the responses. Thank you. Harry. Now, actually, when you are taking center of gravity, you have taken the weight. You have taken the weight because weight is the force. Weight is the force. Force into the distance is the moment. Therefore, here you have taken the weight. Here you have taken the weight. So, when you are taking center of mass, you can do the same procedure. You can do the same procedure, but instead of weight, you have to apply mass. Instead of weight, you have to apply mass. You have to apply mass. Therefore, center of mass. You have to do the same thing. You have to do the same thing. Here you have to apply weight. Here you have to apply mass. That is the only thing. And you have to make a center of mass here. Suppose this is center of mass. Center of mass normally we call Cm. X bar, Y bar. Therefore, this part is Y bar. Here X bar. Center of mass. Therefore, Okay. So here we have to do the same thing. So instead of considering weight, we have to consider mass only. And that means the total mass is 1 to 10 kg. Therefore, 10 into, if you take momentum about y-axis, 10 into x bar, 10 into x bar, 100 into x bar, they have initially 100 into x bar, now 10 into x bar. Now instead of considering weight, now we are going to consider mass volume. 10 into x bar is equal 2 into 2 into, sorry, x is sorry, 2 into 1, 1 into 2, 2 into 1, 1 into 2, 2 into 1 plus 1 into 1, 1 into 1. ඊළඟට 3 into 3 into 3. මෙතන 3 නේ 3 into 3, 4 into 3. 3 into 3 plus 4 into 3. The same thing, same thing. And therefore, definitely x bar is equal to this one. මේක වදාව ඉතින් වෙනසක් නැහැ. Therefore, x bar is equal to 2.4. So actually, center of mass and center of gravity, actually those are two different, two different physical quantities. But for small masses, both are same. I will explain what is the reason. I will explain what is the reason. For small masses, both are same. I will explain what is the reason with definition. And then, if I take momentum on x-axis to be 10 into y bar is equal 2 into 2, 3 into 2, 2 into 2 plus 3 into 2 plus 1 into 4, 4 into 4, 1 into 4, 4 into 4, 1 into 4 plus 4 into 4. Therefore, y bar is equal. So this is the way of determining the center of mass. Therefore, when you are actually, if you want to take center of mass, you just need to do the same procedure. Instead of weight, you have to apply mass. You have to apply mass. Did you get my explanation? If you get this one, please raise the hand. Okay, thank you, Bude. Now you can write this one. This is the way you calculate center of gravity. This is the way you calculate. This is the way you have to calculate center of mass. Okay, so if you can divide the book into 2, it will be much better. Okay, shall I erase? Have you completed? Okay. Alright. There are the topic definition. Definition of set of mass. Definition of set of mass. Okay with it. Look at this one. Suppose now there's a mass like this. Suppose this is our coordinate, Cartesian coordinate. And this mass consists of some small particles M1, M2, M3, like M8. Particles theorem. Likewise, there are a lot of particles. And now, suppose the distance from the origin to each particle is R1, R2, R3, R8. And let's say This is the center of mass. This is the center of mass. Center of mass means that is the addition of all masses. That is the addition of all masses. Let's say that is capital A. Capital A. So this is the center of mass. Right? Center of mass. Okay, total mass is capital input. Now I can take the distance from the origin to this one. Suppose this is RCM. 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 So, according to our initial principle, actually mass into distance may about same axis. Mass into distance about same axis. We can may equate may for the resultant mass and the resultant of other masses. And so according to so that is the principle of moment. There is no principle of moment. So this is the definition of center of mass. Therefore, resultant mass is input. Distance from the origin of certain point is equal RCM. So this is the resultant. Resultant mass into distance. Resultant mass into distance. The total mass into distance. Total mass here distance. Then that is equal M1 R1 plus M2 R2 plus M3 R3 plus Mn. Therefore, distance to center of mass can be determined. Okay, so that is equal to M1 R1 plus M2 R2 plus M3 R3 plus Mn Rn divided by the total mass. Divided by the total mass. Actually, this is the this is definition put, but may also this is the definition. We can use our previous theorem to that. So this is the definition of center of mass. Did you get my point? Hema? Total mass into distance is equal mass into distance of each particle. Mass into distance. Sorry, addition of mass into distance of each particle around the same point. If you got that one, please raise the hand. Thank you. Bye. Hello, Buddha. How da? Okay. There are topic. Relationship between center of mass and center of gravity. Relationship between center of mass and center of gravity. Center of mass and center of gravity. Right. So this is definition of center of mass. Center of mass. Suppose if I multiply both denominator and numerator by gravitational acceleration, then what will happen? If I multiply both numerator and denominator by gravitational acceleration, then what will happen? Then RCM is equal M1G R1 plus M2G R2 plus M3G R3 plus Omega Mn G Rn over total weight. Ute, what is this? What is this? If we multiply both sides by gravitational acceleration, then what will happen? Sorry, this. Now instead of mass, now there's weight. So what is this? So this is the definition of center of gravity. This is the definition of center of gravity. So this is the definition of center of gravity. That means center of gravity and center of mass both are same. Is it correct? ඒකද කියන්නේ? ඒක හරියද? හ්ම්? බලන්න. That means center of gravity and center of mass are same. Is it correct? පුතේ ඒක හරියද? එතන. එහෙම වෙන එක හරියද? Can anyone explain that to me? Yeah. Actually, according to this mathematical equation, that is correct. Center of mass and center of gravity are equal now. But there's a problem, Pute. There's a problem. There's a problem, Pute. Pute, බලන්න, weight means mass into gravitational acceleration, Pute. Mass into gravitational acceleration. So, if it is a small object, gravitational acceleration, if it is a small object with a gravitational acceleration at this point, and gravitational acceleration at this point, all are same. Therefore, gravitational acceleration for all objects are same. Therefore, gravitational acceleration for M1, M2, M3, Mn, all are same for small objects. That means weights of a small object, if you take the weights of a small object, the gravitational acceleration involved with weights are equal in all cases. Therefore, in such cases, center of gravity and center of masses are equal. But suppose if you want to find the center of mass, something like a mountain or something. So it is very clear, if you consider a mountain, it has a height more than 1 kilometer, 2 kilometer. Therefore, definitely the gravitational acceleration at this point is different than the gravitational acceleration somewhere here. Therefore, if we consider about very huge mass relative to Earth, definitely gravitational acceleration may vary from location to location. Therefore, if you consider about center of gravity, the weight of each object is not equal to mg. Here, the weight of this object is mg. Here, weight of this object is mg dash. Then mg3. Likewise, location to location, gravitational acceleration may be variable. Therefore, in such cases, G is not common for all masses. G is not common for all masses. If G is common for all mass particles, then center of gravity and center of mass are equal. But if not, that means if the center of gravity for all particles are not equal, in such cases, center of gravity and center of mass are not equal. Did you get my point? පැහැදිලිද? තේරුණා පුස්සා? I need responses from everyone. තේරුණා කියන්න. Okay. Then write this one. I write up to this with a value. Okay, right under that. That means if the gravitational acceleration for all mass particles, if the gravitational acceleration for all mass particles gravitational accelerations for all mass particles are equal, then the center of mass and center of gravity are equal. Center of mass and center of gravity are equal. But if we consider a mass, if we consider a relatively large mass, if we consider a relatively large mass, within brackets, like mountains, gravitational accelerations vary from point to point. In such cases, center of mass and center of mass and center of gravity are not equal. In such cases, center of mass and center of gravity are not equal. Center of mass and center of gravity are equal for small objects, and center of gravity and center of mass are not equal for relatively large object. Get that? Okay. There are a topic. The relationship between center of mass and linear momentum. Center of mass and linear momentum. Alright. බලන්න. දැන් මේක තමයි හොඳට මාර්ග ඉන්න එක තමයි. එවුලා please look at the board. කට්ටිය බලාගන්න. හරි. පොඩ්ඩක් උඩ ටිකක් උඩ වැල්ලා වගේ ආවල ගන්න. හරි. බලන්න පුතේ. එවුලා please look at the board. Now we are going to discuss about center of mass and relationship between center of mass and the linear momentum. Puti. So that is the lesson. Puti. Okay. So what is the center of mass? Actually, center of mass is the point where the entire mass of the system is concentrated. Center of mass is a point where the entire mass of the system or of an object is concentrated. Therefore, the total mass of the object, is concentrated at center of mass. Therefore, any object can be considered as a particle, very tiny particle, which is concentrated to the center of mass, because the entire mass is concentrated at center of mass. Therefore, I can consider now there's an object. Now there's an object with capital M mass at this point. එහෙනම් මට මෙන්න මෙතන තියෙන capital M mass එක කියලා මේක හිතන්න පුළුවන්. Therefore, because the entire mass of the object is concentrated at this point. Therefore, without considering all the other point, I can consider this object as a point object which has capital M mass and located at that point. Is that okay? If you got that one, please raise the hand. If you got that one, please raise the hand. Hey, Pranatusan. Thank you. Gandhi. Okay. Okay. Now I can any object can be considered as a point object which is located at the center of mass. Have. Now I will write down this. Center of mass is the point. Center of mass is the point where the entire mass of the object is concentrated. Where the entire mass of the object is concentrated. Therefore, any object can be considered as a point object. Therefore, any object can be considered as a point object any object can be considered as a point object which is located at the center of mass of the particular object. Which is located at the center of mass of the particular object. Draw this one. Okay, Uday. Hi. Now, very well. Everyone, please look at the board. Now you know. Now there's a object to the. Now there's a capital N particle like capital N at this position. And now this is a mass. Now you know, according to Newton's first law, the current state of any mass or current state of any object can be changed by applying an external unbalanced force. On the other hand, if there is no external unbalanced force, the current state of any mass remains unchanged. Therefore, suppose now there is a object system with it. Now there's an object system in evolution. Now there's an object system with it. Now there are two objects to put it. So we can consider this one as an object system. So if there is no external force exerted on this system, the center of mass of the entire system cannot be changed with it. Because according to Newton's first law, the current position or current state of any mass can change if there is a external unbalanced force only put. If there's no external unbalanced force, the current position or current state of any mass cannot be changed. That means if there is no external force on the system, the center of mass of the system should be a constant. That means the position or movement of center of mass will not be changed. That means the current condition or current state of the center of mass will not be changed. Did you get my point? If you got my point, please raise the hand because this is the heart. Okay. If you got my point, please raise the hand. That's it. What about others? Thank you, Shashwardhan. Anita. Only two. Okay, everyone, please listen to me. Everyone, please listen to me. May I come? I will explain, but I will explain. Everyone, please listen to me then. Okay, up to this one, you know, is there any problem up to this one? Question. If you got up to this one, please raise that. Now tell me, what is the meaning of Newton's first law? What is the meaning of Newton's first law? I need answers from you. What is the meaning of Newton's first law? Anand, what is the meaning of Newton's first law? Ashok? What is the meaning of Newton's first law? Hmm? Gandhi? What is the meaning of say Newton's first law again? First law again මොකක්ද කියවෙන්නේ? first law කියන්න බලන්න. meaning එකක් ඕන කියන්න නිකන් just මේ definition law එක කියන්නේ. law එකේ තියෙන meaning එක. I need responses. I need responses. So what is Newton's first law? Yes, that is the meaning, Pute. That is the meaning. And so suppose now there is an object. And now there's an object. Now, without drawing an object, remember, right? Now there's an object. So without drawing an object, I can draw the mass, a mass at the center of mass, no? Because any object can be equivalent to a mass at the center of mass. Because the mass of the object, the entire mass of the object is concentrated at the center of mass. Therefore, no need to worry about this much of object because all the mass is concentrated at a single point. Therefore, without considering of this large object, I can consider this one as a point object. That means point object whose mass is exerted at the center of mass. So now this object is equivalent to this point object. Now this is the point object. Point object means there is object with it. Huh? Huh. So, therefore, according to Newton's first law, if there's no external force, exerted on this object, the current condition or current moving condition of this object will not be changed. It will remain unchanged. Did you get my point? That is Newton's first law. If you got that one, please raise the hand. If you got that one, please raise the hand. Harry. Now, look at this. Look at this. That means if there is no force, if there is no external unbalanced force, more than that, there can be two options. There will be two options. No. If it is in rest condition, it will remain at rest condition. It will remain at rest condition. If it is in moving condition, it will continue the same moving condition. If it is in moving condition, it will continue the same moving condition without change. It will continue the same moving condition, same path without change. Did you get my point? If you get that point, please raise the hand. That means that means if there is no external force, this object, if this object is at rest condition, it will remain at rest condition. If this object is moving condition, it will continue the same moving pattern without changing anything. Did you get one? Did you get that one? If you get that one, please raise the hand. Otherwise, please let me know if you want any explanation. තේරෙනවද තුසන්? මම හැමෝගෙම රෙස්පොන්ඩ් එකක් ඕනේ. මම කරේ වේඩයක්. කතන්දරයක් තියෙන දණක් මම හැමෝගෙම රෙස්පොන්ඩ් එකක් දෙනකොට මට හොඳයි. Okay. දහම් දියෝ කරේ. හරි. ශෂ්වත ඕකේනේ? ආ. හරි ඔකේ. මේක තේරුම් ගත්තොත් හරි ලේසියි වනේ. Ah. If you understood this part, that will be very easy. If not, then it is very hard. Okay, like if you understood, then it will be very easy. If not, that will be very hard. Okay, and on now we can may apply this knowledge to collisions. Now we can apply this knowledge to collision. But now look at this one. Now there is a system of masses. Now there is a system of masses. Have a system of masses. That means there are two masses. Now there are two masses. So if we consider the center of mass of the system, we can define the center of mass. That means suppose now there is one object. Sorry, it has m1 mass. Now there is another object. It has m2 mass. Okay. Suppose from this point, if you consider about this kind of point, the distance to this mass is R1. Distance to this mass is R2. And then you can determine the center of mass. Now you can determine the center of mass. Therefore, if the center of mass is X, then X. If the center of mass is X, therefore total mass is M1 plus M2 X is equal M1 R1 plus M2 R2. Then you can determine the center of mass. Center of mass means M1 R1 plus M2 R2 over M1 plus M2. So that is the center of mass. That is the center of mass of this entire system. That is center of mass of this entire system. Did you get my point? May system में कैसे center of mass से कोई पे दे दो. Did you get my calculation? How I calculate the center of mass of this system? Did you get that one? If you get that one, please raise the hand. My system में center of mass के क्या मत देना मैं? हर काम विधि बता मैं. Now look at the most beautiful thing put. Look at this one. Now suppose now these objects are moving towards each other and collision. Suppose this collision is elastic collision. No, actually not about elastic collision. If you consider any collision, we can take there is no any external force moving. If we consider about a collision, pute, there is no any external force. All internal force. Therefore, suppose if these two mass moves towards and collision each other, without any external unbalanced force, without any friction or any external unbalanced force. If so, as there is no any external force exerted on this system, the center of mass of this system cannot be changed with it. It cannot be changed. Did you get my point? Center of mass එක වෙනස් වෙන්න බෑ කියලා තේරෙනවා. Collision එකක් වුණා කියලා center of mass එක වෙනස් වෙන්න බෑ කියලා තේරෙනවා. Did you get that one? පැහැදිලිද? If you get that term, please raise the hand. Theorem of the sun. Because during the collision, there is no external force put in. During the collision, there is no external force. All are internal forces. Therefore, although there's a collision, as there's no any external unbalanced force on the system, definitely the center of mass of the system will not be changed. It will remain unchanged. If you got my argument, please raise the hand. ඒක තේරුණා තුස්සන්. I need responses from everyone. But I said හැමෝම තුස්සන් කියන්නේ හැමෝම තුස්සන් කියන්නේ තේරුණා තුස්සන්. Thank you. Thank you, Pratik. Yeah. Okay. Then we can write down the Vienna. Try to remove Kara. Try to remove Kara. According to Newton's first law, according to Newton's first law, according to Newton's first law, come on. If there is no external unbalanced force on a mass, if there is no external unbalanced force on a mass, its current state will not be changed. Its current state will not be changed. Write it on the para. Any mass can be reduced to a point mass at the center of mass of that particular object. At the center of mass of that particular object. Therefore, come on. Applying a force, therefore, applying a force on an object, therefore, applying a force on an object Therefore, applying the force on an object is equivalent to applying a force applying the force to an object at the center of mass. To an object at the center of mass. If there is no external unbalanced force on the center of mass, the center of mass can be either remaining at rest condition or will not change the current moving condition. Then another topic, center of mass during a collision. Center of mass during a collision. Center of mass during a collision. Within the brackets, without any external unbalanced force. Without any external unbalanced force. බලන්න පුතේ මේ. Without going okay. Two. Therefore, I can determine the center of mass. Okay. Suppose center of mass is somewhere here. So you know during the collision, okay, during the collision, actually there are only two equal and opposite impulsive forces. There are only equal and opposite impulsive forces. Therefore, during the collision, there's no external unbalanced force. There's no external unbalanced force. Therefore, there is no external unbalanced force. Is that clear? පැහැදිලිද? එහෙනම් collision එකකදී external unbalanced force එකක් නැහැ. ඒක තේරුණාද? හ්ම්? හරිද? If you got that one, please raise the hand. During a collision, there's no external unbalanced force, only internal. I internal. Correct? Therefore, during the collision, the center of mass of the system cannot be changed. Center of mass of the system cannot be changed. Before collision, I can write center of mass for the way. Therefore, m1 plus m2 into x is equal r1 into m1 r1 plus m2 r2. Therefore, the center of mass for the center of mass is equal x, that is equal m1 r1 plus m2 r2 over m1 plus m2. Pute, now this is the center of mass with respect to this position. And okay. Now, as there's no external unbalanced force during collision, this position cannot be changed. Therefore, as there's no external unbalanced force during collision, this will remain unchanged. And on that, I'm going to take as there is no external unbalanced force during collision, center of mass of the system will not be changed. ඔන්න පුතේ collision එකේ මොකද වෙන්නේ කියලා කිව්වේ. මේ දාගෙන. Another thing. Okay. Shall we do an example? Write this question. Write this question. An object with simple 2m, right? 2m, an object with 2m mass is projected inclined to the horizontal surface. Is projected inclined to the horizontal surface. Inclined to the horizontal surface. Is projected inclined to the horizontal surface. At the highest position of the projectile, the mass explodes into two equal pieces. The mass explodes into two equal pieces. One piece falls freely in vertical downward direction. One piece falls freely in vertical downward direction. Find the location where the second piece is landed on the horizontal surface. Find the location where the second piece is landed on the horizontal surface. Within brackets, take the horizontal range of the projectile. Take the horizontal range of the projectile without any explosion. Take the horizontal range of the projectile without any explosion is capital R. Okay, I will repeat the question again. I will repeat the question again. If you miss anything, you can write down the team. What I gave you. An object with simple two-way mass, an object with simple two-way mass is projected inclined to the horizontal surface is projected inclined to the horizontal surface. The mass or the mass or the object explodes into two equal pieces at the highest point of the projectile. At the highest point of projectile. If one piece falls freely in downward direction, if one piece falls freely in vertical downward direction, find the position where the second piece is landed on the horizontal surface. Where the second piece is landed on the horizontal surface. Within brackets, take the horizontal range of the projectile. Take the horizontal range of the projectile without explosion is capital R. Without explosion is capital R. Nó là cho mình cái áo cái nào cái nào đâu. Hello. Hello. Okay. Look at this one. Now there's an explosion. Now there's an explosion. So explosion means actually there is a force internally. There's no any external force. During explosion, there's a force internally. There's a force internally. Therefore, if we consider about this entire mass system, there's no any external force with it. So during an explosion, definitely there is a internal forces only. Is that clear? Make a පැහැදිලිද? හරි. So if there is no any external force පුතේ, the movement of the center of mass, that means the moving condition of center of mass will not be changed. It will remain unchanged. There is no change of the movement of center of mass. So initially, the center of mass moves along this path with it. It is a projectile. So initially, center of mass moves along this path with it. Moves along this path. Therefore, as there is no any external unbalanced force, it will continue that path with it. It will continue that path. Therefore, center of mass will continue this path. Okay. It will continue this path with it. Therefore, at R over 2 location, the center of mass is there. Center of mass is there. Okay. Now there's an explosion with it. So due to this explosion, one capital simple M mass now falls down to this location. Now simple M mass falls down to this location. Therefore, to have center of mass at this position, the next mass should be located. May mass located? Definitely, it should be located at the same distance. From this location. Because both masses are equal. Therefore, to have the center of mass at this position, the next mass should be located at an equal length from this mass. Is that clear? The main mass within distance equal distance mass මුළු system එකේම center of mass එක මෙතන තියෙනවා. Did you get my point? If you get my point, please raise the hand. තේරුණාද උස්සා? තේරුණාද උස්සා? බලන්න පුතේ මේකේ තියෙන මේ exam questions තියෙනවා මේ exam question තිබ්බ හරි මේ කෙහෙල් මල දන්නේ නැත්නම් ඇත්තටම ඔයා මේ ගාන කොච්චර දුරට මේ උත්තරේ ගන්න බෑ. මේක දන්නවා නම් මේ concept එක දන්නවා නම් ගාන හදන්න දෙයක් තියෙනවා. නෑ ගාන හදන්න දෙයක් නෑ. බලපුවා නම් උත්තරේ දන්නවා. හැබැයි මේ concept එක අපි දැනන් ඉන්නවා. මේ concept එක දන්නේ නැත්නම් මේ ගානවා කොච්චර බලන් ඉතින් හදන්න බෑ. මේ මට මතකදී 2020 වල question නම් මේ වගේ තව questions ගොඩක් තිබ්බා. මේක question එකක් මම මට මතක තිබ්බා. හරි. ඒක මම කියන්නේ මේ center of mass කියන concept එක මාමුතු concept එකක්. මේක ඇතුළේ තියෙන questions ටික බරපතල විදිහේ questions එනවා. හරි බරපතල නෑ ලේසි. හැබැයි මේ theory දන්නේ නැතුව මේ question එක කරන්න බෑ. ඇත්ත කතාවද? මේ theory දන්නේ නැතුව මේ question එක කරන්න බෑ. center of mass කියන කතන්දරේ දන්නේ නැත්නම් center of mass එකට කොහොමද force එක effect එක වෙන්නේ කියලා දන්නේ නැත්නම් pollution එකේදී center of mass එක වෙනස් වෙන්නේ නැහැ කියන කතන්දරේ දන්නේ නැත්නම් මේ වැඩේ කරන්න බෑ. හරි. මේක දාගන්න. දැන් මෙතන masses දෙක equal නැතුව තිබුණා නම් එහෙම ඉතින් අපිට මේක වටේ අර මේ මොමන්ට් එක ගන්නවා වගේ ඉතින් අරන් බලන්න ඕන. දැන් මේක 2 times දුන්නා නම් මොකද මේක 2m මේකෙන් වුණා නම් 3m කියලා හිතන්න. එතන උඩින් 3m තිබ්බකේ. මේක 2m මේක m වුණා නම් එහෙනම් 2m into r over 2 සමානයි m into r වෙනවා. m into r වෙනවා. එහෙනම් මේක r වෙනවා. Percent of mass. මේ question එක තේරෙනවද මට ආයෙත් කතා කරන්න පුතේ? මම explanation එක. තේරෙනවද පොඩ්ඩක් ආයෙත් කතා කරන්න? If you got this one, please raise the hand. I need response from everyone. මට හැමෝගෙම respond එකක් දෙන්න හොඳයි. Thank you. Shashmita. Hi. Thank you. Okay, they write this one today. Maybe there is no external unbalanced force during a collision, during explosion. There is no external unbalanced force during an explosion. Therefore, the moving path of the center of mass, the moving path of the center of mass will not be affected by the explosion. Will not be affected by the explosion. Therefore, the moving path of the center of mass will not be affected by the explosion. Will not be affected by the explosion. Okay, I will repeat it again. There is no external unbalanced force during an explosion. There is no external unbalanced force during an explosion. There is no external unbalanced force during an explosion. Therefore, the moving path of the center of mass, the moving path of the center of mass will not be affected by the explosion. Will not be affected by the explosion. Therefore, when the two pieces are landed, when the two pieces are landed, the center of mass should be located. The center of mass should be located center of mass should be located at the same point, at the same point where the object is landed without explosion. Where the object is landed without explosion. Write it on the para. Now, simple M piece is landed RO2 distance towards the left-hand side from the center of mass. RO2 distance from the, so simple mass is landed RO2 distance to the left-hand side from the center of mass. Therefore, Therefore, to be the center of mass at the same position, to be the center of mass at the same position, the other object, the other object the other object should be landed, should be landed RO2 distance, RO2 distance to the right hand side from the center of mass, to the right hand side from the center of mass. Then next topic would be point or place of collision using center of mass. Place of collision using center of mass. මේකත් මාරු කතන්දරයක් තියෙනවා. But as we discussed with you earlier, as we discussed earlier, during a collision, if there's no any external force, definitely during a collision, there is no any external force because impulsive force are internal forces. Therefore, during a collision, there's no any external force. If there's any if there are no any resistive forces, there's no external force during a collision or line turn. Therefore, during a collision, the center of mass cannot be changed. Center of mass cannot be changed. And okay. So if there is a collision, බලන්න, if there's a collision, then definitely both objects should meet at a certain point. Both objects should meet at a certain point. Look at this one. If this point is somewhere here, now this is the center of mass. Suppose if this point is somewhere here, then what will happen? If this point is somewhere here, then what will happen? Then now where the center of mass is? Now where the center of mass is? Definitely, it cannot be at this point. Definitely, it will move to this location, no, this side. Because now masses are here, therefore, center of mass will move to this side. Is that clear? If it is clear, please raise hand. Please raise the hand. If the objects collides at this kind of position, the center of mass will shift to this side. If you got that one, please raise the hand. එක තේරුණා තුස්සනපති මේ දෙන්න මේ වගේ තැනක කොලිඩ් වුණොත් එහෙම center of mass එක මෙතන තිබ්බ එක මේ පැත්තට එනවා. And if you got that one, please raise the hand. Thank you. Then this is case 1. Here case 2. Now this is the original center of mass. Original center of mass. Now suppose if the objects collide at this kind of position, if they collide with this kind of position, then what will happen? Now the mass are concentrated at this side today. Therefore, center of mass will be shifted towards this point. Is that clear? If you got that one, please raise the hand. Then masses ටික මේ පැත්තේ තියෙන පුතේ එන center of mass එක කවදාවත් එයාගෙන් එහා පැත්තේ තියෙන්න බෑ. එහෙනම් මේ පැත්තට shift වෙනවා. ඒක තේරුණා තුස්සන්? ඒක තේරුණා තුස්සන්? I need responses from everyone. Okay. Then tell me to maintain the center of mass at this original position, where should these two masses collide පුතේ? Okay, I will explain it. බලන්න. දැන් බලන්න පුතේ මේ if these two masses, suppose these two masses collides at this kind of position. They can make center of mass එක මෙතන තියෙන පුතේ නේ. මේක තමයි center of mass එක initially. හරිද? දැන් මේ දෙන්න collide උනේ මේ වගේ තැනක හිතන්න. මේ වගේ තැනක collide වුණොත් මොකද වෙන්නේ? If they collide somewhere here, what will happen? Now the masses are concentrated to this side. මේ පැත්ත තමයි concentrate වෙලා තියෙන්නේ. Therefore, definitely, now the center of mass of the system should shift to this location, no? Then මෙතනට shift වෙනවා මේ පැත්තට. ඉතින් මේක around තමයි තියෙනවා. හරිද? මෙහි යන්න බෑ center of mass එක. දැන් masses තියෙන්නේ මෙහරි. තේරෙනවද? දැන් මෙතන center of mass එක තියෙනවා නම් mass දෙක තියෙනවනේ ඔබ දෙපැත්තේ. නේද? If the center of mass is there, now there are only two masses. Now there are only two masses. So if the center of mass is there, definitely two masses should be around that point. එක පැත්තක තියෙන බෑනේ. එක පැත්තක තිබුණොත් ඒ පැත්තට පනිනවා center of mass. එහෙනම් දැන් center of mass එක තියෙන්නේ මෙන්න මෙතන. ඒක පැහැදිලිද? ඈ? පැහැදිලිද? නැද්ද? Center of mass කියලා කියන්නේ මොකද පුතේ? Center of mass කියලා කියන්නේ මෑස් එක තියෙන තැනනේ පුතේ. ඒ කියන්නේ මෑස් එක කන්සන්ට්‍රේට් වෙලා තියෙන තැන. දැන් මෑස් එක තියෙන්නේ මෙතනනේ. ඉතින් මෙතන මෑස් එක තියෙනවා නම් දැන් මෙතනනේ තියෙන්න ඕනේ center of mass එක. Is that clear? Center of mass means that is the place where the mass is concentrated. Now the entire mass is concentrated at this position. Therefore, center of mass should be at this position. Is that clear? Ah. So if the collision take place at this position, now the entire mass of the system is at this position. Therefore, now the center of mass should be somewhere here. Center of mass should be somewhere here. Therefore, if the collision take place this kind of place or this kind of place, definitely the center of mass will be shifted. That cannot be happen because there is no any external force. There is no any external force on the system, Puti. Therefore, the center of mass of the system cannot be changed. It cannot be changed. Therefore, definitely the collision should be occurred exactly at the center of mass, Puti. Exactly at the center of mass. Because if the collision is occurred, all the masses are concentrated at a particular point. That particular point should be the center of mass. Yeah, it should be the center of mass because center of mass cannot be changed. Cannot be changed because there's no any external force on the system. Did you get my point? If you get my point, please raise the hand. I need responses from everyone. Did it? Again, I'm going to say, therefore, center of mass cannot be changed. Center of mass cannot be changed because there's no external force on the system. Therefore, collision should take place. Collisions should take place at the center of mass, exactly at the center of mass. Therefore, collision should take place exactly at the center of mass. And make a cannot be happen. This cannot be happen. It cannot be happen. So definitely the collision should occur exactly at the center of mass. Therefore, collision should occur at the center of mass. Write this one. Make a name. Make a table on Atusan, put make a table on Atusan. If you got that one, please raise the hand. Thank you. Arabati. I finish. Okay, then write this one. Write down this. As there is no external unbalanced force on the system. As there is no external unbalanced force on the system. As there is no external unbalanced force on the system. As there is no external unbalanced force on the system. The location of center of mass cannot be changed. The location of center of mass cannot be changed. Therefore, collisions should be occurred. Therefore, collisions should be occurred exactly at the center of mass. Exactly at the center of mass. Okay. Did you get it? Did you get it? Get it? The collision should occur exactly at the center of mass. Okay. Because center of mass cannot be changed as there is no any external unbalanced force. Therefore, if there's a collision, the collision should occur exactly at the center of mass, because when the collision is occurred, all the masses are concentrated at that position. So if the collision is occurred somewhere else, the entire mass is concentrated somewhere else. Therefore, if the collision is occurred somewhere else, the center of mass can be shifted to that position. That cannot be happen. Therefore, collision should occur exactly at the location of the center of mass. Okay. If you got that one, please raise the hand. finally. Have. So this is the theory behind set of mass. Okay, we have done only one question. One question, but there are a lot of questions in our tude. So please go through those tudes, especially questions based on center of mass, especially question based on center of mass. So please go through those questions. So if you can, or if you have any free time, uh, do the questions tomorrow and send that to me before Tuesday morning. And as I discussed you earlier, Tuesday morning you will be given MCQ paper, 2 hour MCQ paper. So that is not the exam, but there is a preparation for exam, because I need to have the exam in standard way පුතේ. මොකද standard way එක අනිවාර්ය exam එකක් තියෙන්න ඕනි. exam එකක් standard way එකක් තියෙන්න අනිවාර්ය ඕගොල්ලෝකට මේ prepare වෙන්න. ඕගොල්ලෝකට prepare වෙන්නේ නැතුව exam එක නිකන් තියන්න හදලා තියලා හරියන්නේ නැහැ. මොකද එතකොට අපිට මේ Tuesday අපේ first term එකේ ඔය තියෙන කතන්දර ටික ඉවර කරගන්න පුළුවන්. ඊට පස්සේ මේ week එකේ මම ඕගොල්ලන්ට notes ටික එවනවා rotational motion එකයි fluid studies වලට. rotational motion and fluid study නෝට් එක ඩිලිවර් කරනවා. මොකද ඒක අපිට නෝට් එක ටික ලොකු ටිකක් තියෙනවා, ඒ නිසා ඒක මේ ටයිම් එක සේව් කරගන්න පුළුවන්. ටයිම් එක සේව් කරගන්න පුළුවන්. ටක් ගාලා මේ නෝට් එක ලියන්න දෙයක් නැහැනේ. විස්තර කරලා ක්වෙස්චන්ස් කරන්න තියෙන එතකොට. මේ ඒක විතරයි වගේ මෙතනට කරේ. ඊළඟට සිම්පල් හාමොනික් මොෂන්ස් වලටත් ගොඩක් වෙලාවට ඒ විදිහට තමයි කරන්නේ. හරි. මොකද ඒක පාඩම් එච්චර අමාරු පාඩම් නෙවෙයි. කියන්නේ හැබැයි නෝට් එක ගොඩක් දිග. නෝට් එක දිග වුණාට පස්සේ ආයෙ ලොකු ටයිම් එකක් යනවා නිකන් බොරුවට. නෝට් එක නොදිත් දැන් මොකද ඒක අර පොඩ්ඩක් ළමයිට ඒක විස්තර සහිතව කියලා දෙන්න ඕනේ දැන් ඒක. හරි. ඒක නිසා මම නෝට් එකේ වැඩ ඉවරම පුතේ නෝට් එක ඉගෙන පාඩම පටන් ගන්න කලින් නෝට් එක ඔයගොල්ලෝ අතේ තියෙන්න ඕනේ. ඒක නිසා එතකොට අපේ එක්සෑම් එක තියෙන්නේ කෙලින්ම ඊළඟ සන්ඩේ කියලා කියන්නේ මේ 15th of June. හරිද? එදාට එක්සෑම් එක තියෙනවා. සන්ඩේ එක්සෑම් එක තියෙනවා. ඊට පස්සේ අපි ටියුස්ඩේ අපි එක්සෑම් එකේ ඩිස්කෂන් එකක් යන්නේ. ඊළඟ එක්සෑම් එක ටියුස්ඩේ ඊළඟට 22 ඉඳන් අපි ඊට පස්සේ අපේ මේ විතුරු පාඩම් ටික පටන් ගමු. කවුරු හරි දරුවෙක් ඉන්නවනම් මොකක් හරි ඔයගොල්ලන්ගේ ටර්ම් ටෙස්ට් වල හරියන්නේ මොනවද? දැන් ටර්ම් ටෙස්ට් තියෙනවද මේ දවස්වල? මොකක් හරි එහෙම කතාවක් කිව්වොත් මොකද ජූන් හරි ජුලයි හරි ටර්ම් ටෙස්ට් තියෙනවා. ටර්ම් ටෙස්ට් තියෙනවා පොඩ්ඩක් කියන්න. rotational motion part එක සහ rotational motion part එක සහ මේ fluid statics අවශ්‍ය වෙයි. එහෙම වුණොත් අපි බලමු 17th of June අපි ඒක පටන් අරගෙන ඊට පස්සේ වෙලාවක් එක්ක ඩිස්කෂන් කරන්න බලමු. ඒක එන විදිහට ඒක ළමයි එක්ක ඩිස්කස් කරලා හොඳයි. එහෙනම් මේ විදිහට වැඩේ කරමු. එහෙනම් next Tuesday 6:30 a.m. උදේහාමට. Okay everyone. එහෙනම් good night පුතේ. ආයුබෝවන්. Thank you පුතේ. Good night. Welcome.